You know, we're experiencing some Amatan over here, which is our winter.
It doesn't get cold, really. It doesn't really get cold.
Dr. Badewa, it looks like winter. It's like winter.
Yeah, no snow though, right?
He's talking about maybe 75 degrees weather.
These are the conversations I have with my mother. Good morning, Mom. How's Florida? Oh, it's chilly today. It's 74. Oh, too bad. It's minus 25. How are you?
Yeah,
You know,
really.
it's all relative to what you're used to.
No, Robbie. Haven't you noticed I'm always in sweater? And this is inside the house.
But you know, right now, I'm putting on my sweater, my winter sweater, actually.
Come visit. Come visit in the winter.
All right, George.
Well.
You're welcome here. Thank you. So
just hope the wind doesn't blow the power out.
I'm trying to welcome the participants at the moment. Okay. We have a good number of people who have arrived early this morning.
Wonderful.
Yes, and we have a junior day secondary school from Kwali.
Awesome. Let's appreciate them for being on time.
Good morning.
Awesome.
I know it's quite some distance. You know, we're traveling approximately an hour and a half from the city center. So that's quite interesting.
That's commendable.
Yes.
It surely is.
We appreciate it.
Absolutely.
And the second school we have right here, they arrived in good time. Abuja at 30.
Yes. Awesome.
Welcome, Abuja.
Welcome, Abuja 30.
And then we have some participants from School for the Blind. Please, how many have arrived? Just 2.
Okay.
Welcome.
The rest are
welcome. You're representing your school, so that's good. Yes, indeed.
And let us appreciate our media team. Just put it on you guys. Dr. Badewa, we need to appreciate the media team.
Oh, they've done a great job.
Yes, absolutely. Well done, guys. We're grateful.
Mr. George, you could send in your request early enough.
And they'll fly out here.
Your music or your video request.
That sounds great.
All right. And also we have the staff from the Royal School of Educational Therapy Foundation.
Yay! Staff. Welcome.
Thank you.
Today we're going to implement a new seating arrangement. Yes, I know everybody has gotten a permanent seat. Right? Have you met teachers from the other schools? You know someone's name? Dr. Badewa.
Yeah, really.
Permit me to say this before you record. Have you started recording?
Yes, you guys are the ones recording over there. You're the hosts.
Oh, I'm sorry. I shouldn't say this anymore.
Tell him to pause the recording.
All right. Well, I can make a suggestion for how teachers can find each other. Choose by either topic area that you teach or secondary special needs of your children. So if you teach at a school for the blind, what is a secondary special needs that you frequently deal with? And see if you can find some other teachers who are doing the same.
Okay, that's a good one. The school with that have an inclusive program, it will really be good for them to mix because they have all sorts of children in there.
Yep.
So I think most of the children are Okay, Mr. Thompson, I'll be curious to know, the school with the inclusive program, is it inclusive solely based on intellectual disability, or does it include other disabilities?
Abuja, that's Kwali also is inclusive. They have, you have mixed students. Am I right? Okay, and same for Abuja Atati. So 2 schools have that same feature.
Okay, interesting. That's good.
Good.
It's good. Yeah.
And I think they're seated close by.
Okay.
Please, when do we start?
9:15, we were informed. What time is it?
9:15.
It is exactly 9:15 with you guys, 3:15 here. Okay.
All right, thank you very much. Do I start at my end or?
You can just do the quick introduction and then
Okay.
I'll take it from there.
All right, thank you. Good morning, everyone, once again. My name is Thompson, like we had earlier introduced ourselves, but today I'll be the MC. So I'll be emceeing the program. More of what we want to do is to talk to the teachers and engage the STEM curriculum. So the STEM curriculum will be administered to the teachers today. I want to welcome you all, Abuja Ateti, also Junior Day Secondary School, Kwali, and also the School for the Blind. You're welcome once again. While we await those who are on their way, we'll continue with today's program. So I also want to thank the school, Royal School of Educational Therapy Foundation. You're welcome. And also want to thank everyone that has been participating from the very first day. You had shown the passion, the interest, and also the commitment by coming and being punctual. This is commendable, and we want to say that at the end, we hope that this program would, actualize the goals and the objectives. So once again, welcome. I would quickly move on onto the online presenters today. Today we'll be having online presenters, so get ready. This is going to be a hybrid session where we have the online presenters administering the lectures to the in-class participants. So please let us start with Mr. George. Mr. George is a consultant for One Planet Education Network in the United States of America. Mr. George has vast expertise in the field of STEM implementation in schools and all over, in most places in the East Africa. And I think he has been engaging schools also in Nigeria. So we want to welcome Mr. George Newman. Thank you very much.
Thank you very much, Mr. Thompson, very much. Welcome, everybody. Thank you. I presume that many of you were there on Monday, the first day, where I gave an explanation a bit about open and our background and STEM, as well as the kinds of programs that we offer with technology in education. And we're in about 15 countries now, and 5 in Africa. I'll list them, Nigeria being one, where we are today, Liberia, Kenya, Congo, the Democratic Republic of the Congo, and Malawi. We're also in Australia. We're in the US in New York City schools, soon to be in Hawaii schools, and Jamaica is forthcoming. We're also doing some work in other programs, not STEM related, but other education programs, learning about one another's culture through music in China, Japan, Malaysia, and Thailand. And we're looking at other countries like Colombia and Trinidad. I mentioned Jamaica. are going to be forthcoming. So the opportunities for you all, if you join our network in some way, shape, or form, would be to communicate and collaborate not only among yourselves, but with those other country schools. And we're following a similar path together, focusing on sustainable community development and using new technologies like the STEM sensor kits you're going to be working with tomorrow to utilize not only in the classroom and learn the new skill sets that hopefully will lead to rewarding careers and jobs, but also to deploy this technology in the community for the community's benefit. So we're doing mainly a focus on sustainable agriculture. And that's what these sensors are that you're going to be building tomorrow, of which here is one of them, a little circuit board that will be, as you put it out into, let me just put that up closer, as you would build this by your own hands tomorrow. And I think even though it's small, you'll not have a problem in putting that together. And that's what we need back from you. We need back from you, the school, your schools and your students. We need your feedback during this session so that we can, get an understanding of whether this can really work with your classrooms and with your students. Thank you, Mr. Thompson.
Thank you, Mr. George Newman. We would actually retake some of these introductions because we have half of the participants here present at the moment. I think that was a lot of information for now. We'll just hope that when others come, Mr. George, you can then repeat the introduction. Thank you very much.
Sure.
This will be a very brief introduction, I believe. And next, I would want to introduce Miss Eda Cowap. Thank you very much. She's also
morning, everybody.
One of our consultants, also from One Planet Education Network. And she's been doing a great job also in implementing STEM in agriculture. And she's more having in-depth expertise in applying STEM for agricultural purpose and also environmental assessment. So over to you, Ms. Eda.
So good morning, everybody. I'm an education consultant. So my background is 15 years of teaching high school biology, chemistry, molecular genetics, and genetic diseases and microbiology. So like you, I'm a teacher. I've taught a wide range of students, and I'm looking forward to working with you over the next 3 days to look how to design lessons and integrate STEM into your classrooms, and having some time for collaboration to come up with ways to go back to your schools and actually put this to work. So, Mr. Thompson.
Thank you very much. Like I earlier said, we'll retake some of these introductions when we have a full in-class attendance. Yes. And also, I'd like to introduce Dr. Badewa Adejugbe-Williams. She's the visionary behind this project. She's done, great work with working with persons with disabilities. She's also vast in everything that concerns the persons with disabilities. So I would like Dr. Badewa to quickly just give a 2-minute introduction.
Saying my name alone takes 2 minutes. Good morning, everybody. This is really a great honor to be here. I'm an educator as well. My background is over various fields, but in education, I'm an educational therapist. That is a specialization in special education. And basically, we do almost the same thing. We do the same thing as special education teachers and psychologists combined, and behaviorists. So I also have background in teaching general education. I've taught from 2nd grade, that's like primary 2, all the way through high school. And then I taught adults, you know, those who migrated to the US and they needed to learn English as a second language. So I was an English as a second language teacher for adult school. I'm a special educator. I'm very proud to be. It's not something I wanted to do. My background, initial background in life was not in education, but I'm a mother. A mother of two very special and very unique and probably the best children anyone could ask for, really. They've just brought fulfillment into my life. They've grounded me, and they're the reason I do this. You know, I put all my energy into them, and as I put into them, my way of giving back is by putting into other people's children. And how can I have more impact on other people's children because I'm not directly with them? The way I can do that is by impacting my knowledge on you, you know, getting others to come and work with us to just build our community. I'm very, very proud to be a Nigerian. And when I see the situation of persons living with disabilities in Nigeria, how they're not really being provided for as they should, it really breaks my heart. So I had to look into myself, what can I do? How can I make a difference? Even if it's just on one child or, you know, one teacher who's gonna go and impact, you know, 20, 30 more teachers. I just believe that collectively we can achieve more. And I also believe in training the trainers. And for the trainers we're training today, to have the ability, the knowledge to also go and train others within their circle of influence at their schools or reach across to other schools so that we can keep building the momentum. And our children, we always worry, as parents, we always worry, what would become of them when they become adults? Do you understand? So what can they achieve? What's the purpose of going to school beyond trying to just put more effort into learning, into gaining some kind of knowledge? So I also believe in purposive education. Let's have them there for a reason. Let's build, let them develop a skill. So as STEM, I mean, believe it or not, our children at the center do really, really well in agriculture. That is part of STEM, you know? So what else can we do? We have some graphic artists. We have a student that is now working at a television station. This is a child with intellectual disability, you know? So the possibilities are there for them. So that's the whole purpose of this. Let's give them more chances in life. Thank you.
Thank you, Dr. Badewa. Let's put the hands together for her once again. And all our presenters online, Mr. George and Ms. Heather. Also, I would like us to note that this workshop is being sponsored by the Public Affairs section of the Embassy of the United States of America in partnership with the Royal School of Educational Therapy Foundation. So, and also in partnership with One Planet Education Network. Thank you very much. I think it's right about time we look through our agenda for the day. And let's open our agenda. I don't know, do we have it with us? So we follow through. The time is approximately 9:30. Can I approximate time? Am I allowed to approximate the time?
Yes.
Okay, thank you. So we're moving on from welcome and introductions to introduction to STEM, IoT, and the RSET RSETF and open projects to train teachers of special needs, students in agricultural sensors, and how to build them. This segment will be coordinated by Dr. Badewa, Mr. George, and Ms. Heather. I don't know who comes first.
Dr. Badewa, you're muted.
Thank you.
Mute. Okay, all right, thanks. So everybody, can you see my screen again? Are you able to see my PowerPoint?
No.
No, just the agenda.
All right, so let me resume share. Okay, hold on. Stop share. Okay, now share again. I thought I was ready. How is now?
It's up.
Okay, great. All right. So as Mr. Thompson rightly said, the program is being sponsored majorly by the U.S. Embassy, the Public Affairs section of the Embassy of the United States of America in Abuja, and also by the Royal School of Education and Therapy Foundation. And we're very, very fortunate to have such competent partners, you know. One Planet Education Network, you'll hear more from him about what they do. And also our consultants, you know, who have worked diligently in helping to train you guys yesterday. I have to give a big thank you to Dr. Okosu and his team, Mr. Thompson and Mr. Nashi. They've been just wonderful. My own team, my own support system, they too, you know, they're there as participants and also as co-facilitators. So I just don't know, how could I be here and they are there and they're functioning without me? And I sleep well at night, knowing that they're very capable. So thank you all very much and welcome to today's session. Now we're getting into the nitty-gritty of what STEM is. We've talked about, you know, the stakeholders, the roles they all have to play, why everybody must buy into this, why it is important for the administrators and you all to know what is expected of you. So now in the classrooms, how do we proceed? How do we now practicalize this project? So we have to always keep going back to the best practices. We have to go back at what's going on all over the world, because as it said, we've been saying for a while now that we're building 21st century children. We want them to really hone in on the skills that everybody else in the world is exposed to. Now, you know, when we talk about this holistically, we realize that we are all already practicing STEM. We're already doing the things. It's just knowing that that's what we're doing, that the children now need to know, oh, so that's why I have to learn science. That is why technology is important, why engineering is important, why mathematics is important. Am I saying all children with special needs will definitely excel in this? No. Even us, even stereotypical children, they don't all excel in this, but everybody's got a strength in something. And if you don't expose them to all of it, you will not know who's good at what. So that's the whole essence why we must make sure that inclusivity, that they've got access to the same curriculum as everybody else. And we'll teach them at their own pace. So STEM teaching, once more, is an interdisciplinary approach to learning, where students learn and apply the concept in science, in technology, engineering, and mathematics. And I'll just go briefly into the definition so I don't take too much time. Science, of course, is the process of finding out about the world and how it works by exploring, gathering data, looking for relationships and patterns, and generating explanations and ideas using evidence. Then it's the same thing, making predictions, sharing discoveries with each other, asking questions and wondering how things work. There is a methodology or a philosophy in education that the best approach for children with special needs is discovery learning. Okay, they are exploring, not knowing that they're actually learning. And as they're exploring, they discover, you know, new things and they learn new knowledge. So STEM science fits right into that. Technology is using tools that have been designed to meet human needs, such as balance scales, comparing weights, lenses to look closely at living things, and digital tools like computers. When we talk about technology, it's not only about computers. Even in special education, we talk about assistive technology. A piece of paper could be considered an assistive technology. How so? Because we enhance it to make sure that that child who's squint, who cannot read very well, or who writes really big, we make sure the lines are big enough for the child to be able to write. A child with poor pencil grip, we get him a bigger pencil that he can grip properly, or we give him a pencil grip to help him. These are all technology tools. And it took people who study technology to be able to come up with these things that are making lives easier for persons with disabilities. So it entails being inventive identify where a problem is and making sure that we solve that problem, make things work. You know, your microwave, your oven, your gas cooker, making things work. Engineering is the process of designing tool systems and structures that help humans meet their needs or solve problems. We all, you know, you live in a house. It took engineers to put these things together. What is it that you need? It's about structures that help humans meet their needs or solve problems. If you are noticing the pattern here, STEM is about solving problems. Okay, so engineering is using a variety of materials, designing and creating and building things that work. Technology is making things work. Engineers build it to make sure that it does work. And mathematics, the study of quantities. How many? How much? The study of structures. What are the shape? What type of house are we going to build? You link that into engineering. Angles and distances and change. It's sequencing. It's about patterns, exploring shapes. And it's the patterns, the binary codes that are being used in software developers in technology. So you see how they are all connected. So children naturally, they explore, they play with objects, they build things. And, you know, as they're building things, they're discovering things. You give them Lego and they build houses, or they build, it could be a shape, it could be just anything they want. Especially children with disabilities, they really do well when they're building things, when they're using their hands. So when a child builds a tower with Lego or any type of building block, the child is already exploring engineering skills in building that structure. They use science also as they explore these blocks and these different materials and shapes. So they're already practicing this in every little thing they do. It can be planned, it can be unplanned, especially if you're in the classroom, you are planning. But sometimes we talked about something the other day about deliberate mistake. Sometimes you're not even planning it, but you see that the child is doing something and you use that opportunity to teach that concept. So good teaching is intentional teaching, which is planned, but teachable moments can happen at any time. So those are the times that, oh, the child built a triangle. Let me now teach about triangle. So carefully planned activities and materials can inspire and incite children's natural desires to explore. And this can lead to spontaneous teaching and learning. Engage children with thoughtful and intentional learning activities that invite them to engage in STEM. You have to really critically know your children, know what they like, before you can now bring in the kind of project or activity that they will engage in. So you have to be intentional about what you are presenting. So you can do different things like building ramps. We say, well, we don't have the technology. Yes, we do. We can just go get a piece of wood or a plank, cut it down and use it as a ramp. So there's some things in our natural environment that we don't necessarily have to go and buy, but that we can just be very creative and inventive and use for these children to explore STEM. Constructing a marble run, planting a garden. Even though everybody at all our schools, we have land. You can plant a garden at your school. And these STEM sensors, actually, it's one of the requirements for you to be able to really gain from these STEM tools. You should plant a garden at your school. That becomes an opportunity to teach STEM. Using a magnifying glass, all these types of stuff are already incorporating STEM. So you have to plan activities that prompt investigation and exploration. When you build a ramp, roll different kinds of objects. To roll a square, a cube, does it roll easily? Roll a sphere, does it roll easily? Make comparisons with that. And that way you are teaching mathematics, you are teaching engineering, you are teaching technology, you are teaching science. So I'm going to stop here because this will come at the end of the lesson about the different strategies. But right now, what I like to do is to hand over to, I've done my spiel. I'm going to now hand over to Mr. George to tell you a little bit more so that you will now be able to make connection as to why you are going to build these STEM tools and use them in your schools for a purpose. Remember, the purpose is for them to be gainfully employed or to start earning a living. So thank you for your time.
Thank you, Dr. Badewa. Welcome again, everybody. Just to give you a quick background on me and how we came to be doing what we do and how it applies to what you're going to be doing this week. I don't come from an education background originally. I'm a technologist, but by my earlier career, but I found my way into education because I was always a little bit, shall we say, feeling that the education could do more. I had the angle from technology and learned early on how this might be applied in the classroom many years ago, even before the invention of the internet or the commercialization of the internet. And I was always thinking, what can you do with what you learn? Where can learning lead to? And we talk about problem solving and applying learning to the community and also the skill sets that students really need. And STEM really kind of gets at that. Problem solving using science, technology, engineering, math, and interdisciplinary approach. But why not look at the problem solving on big societal challenges? That's why we've aligned ourselves with the UN Sustainable Development Goals in taking technology to the next level, not only just using STEM and understanding what it does in the classroom for students' future careers, but also at the same time, why not have them apply it to the community early and often? We are in 15 countries. I've mentioned this earlier. The students in these countries collaborate with Zoom. They do similar projects in agriculture and using these technology kits. Right now, these kits are being used in Australia, New York City, and we have sensor technologies in southern France on a farm there, which is sort of an ecosystem restoration project. And now we want to introduce this technology to you for special needs children, because we really feel students are inventive, creative, and they need hands-on, and we're going to offer that with this. But we do need, as I mentioned before, your feedback on how it might best work with your students. So this next few days, we want it to be pretty interactive, feedback from you along the way. Heather will lead you into the details of STEM inclusion, and I'll hand it over to Heather very soon. But just think about what your students can do among your own schools there, but also if you join us, how we can share this around the world and bring in other schools that are special needs in America, which is what I want to do here, as well in other countries. So I think this could be the beginning of a big movement here. And let's work together closely. And after this workshop is over, hopefully we can continue this and see where it will lead. And we're open for ideas from you on how it can work better and where it can go. But ultimately, jobs out the back end, we want these students to have similar opportunities to others. And we think through this technology, it might be possible to give them a whole new high-tech opportunity that's out there in the global community. So thanks very much. And I hand it over to Heather to take it down to the details of STEM and how we can do this in the classroom. Thank you.
All right, thank you very much, Mr. George. Good morning, everybody. So hold on, give me a second and we'll get a slideshow going here. Here we go. All right, so this is day 1 of 3 days. So we're going to be taking some time over the next few days looking at how do we integrate STEM into curriculum, working with the kits on day 2 so that we can have you actually troubleshoot together where you think kids are going to have problems so that we can offer supports and come up with some creative solutions. And then on the 3rd day, we're going to do a deep dive into some specifically, how do we meet the needs of special needs students in curriculum, and then writing some lesson plans so that when you roll back into school on Monday, you have something in hand that's ready to roll and you're not saying, oh, that was a great weekend, that was so wonderful, but now I have to go back to like the real world and I don't have time to collaborate So we want to make sure, so a fair amount of this time over the next few days will be encouraging you to talk to each other and collaborate across disciplines and across needs of students. All right. So some of these things have already happened. That's why we're flying through here. So let's start with talking about STEM, which Dr. Badewa has done a lovely job of explaining, but I'm going to bring it down to why sensors, right? Okay, so if science is pure inquiry, I make an observation, I come up with a question, I follow a protocol to answer that question, right? That's the heart and soul of science. Then engineering is saying, wow, that really interesting science discovery, I can use that to make something that is useful for humans, usually. That made item becomes technology. And math, of course, is an underscoring language of data analytics that supports all of this. It's part of answering the question of science. It's part of calculating and determining how to do the engineering and the technology piece of the project. Many people include art and say that we shouldn't be talking about STEAM, we should be talking about STEM, rather, we should be talking about STEAM. And the reason for art is that the heart of science, technology, and engineering is also being creative, looking at things in a different way, making observations, being creative about how you put them together, or being creative about how you apply them. And so that creative piece is something that, you know, I think we often, when we think we're teaching science, we forget that kids asking a question out of where we're coming from that maybe doesn't seem to align directly with the concept that we're talking about needs to be encouraged. I used to say to my students, if you look at a cathode ray tube, do you see electrons? Because I don't see electrons, but Rutherford saw electrons. That's a really creative switch in making an observation and coming to a conclusion about data that we can all look at and go, yeah, that's kind of cool. Look, the light goes up and down with the magnet. So where do sensors come into play? Sensors are technology at this point. We have been collecting data about the world around us for many, many years. We've been collecting temperature readings. We've been doing barometric pressure readings. As we've developed the ability to measure things like carbon dioxide and oxygen levels in the atmosphere, we've been doing that. And we've been looking at sort of, soil humidity. We've looked at a lot of different aspects. And each one of those things was a different piece of equipment. Each one of those things required, when we first started doing this, somebody going out, looking at a thermometer, making the reading, bringing that back in, collecting that data, and doing it all by hand analysis. Then we moved to being able to have a thermometer and a barometer that were electronic or digital, and it started to collect the data into a computer. What sensors do for us is they don't have to be directly linked to a platform. They can just collect that data. And now with Bluetooth and with Wi-Fi and with LoRaWAN, which is different ways of collecting that data from the sensors, we're able to amass mega data about what's going on in the world around us. The sensors that you guys are building with your students are designed to be a part of an international data set, and yet also usable on the ground level at that local location. So if I have a sensor in a greenhouse, it's in this example, it's collecting data on the humidity in the air, the temperature of the space. And I'm then able to look at that and say, oh, I need to go water my plants, or there's too much water. Maybe I need to sort of release some of the water vapor from my greenhouse by opening the doors for a while so that it can evaporate out, right? So it's allowing me to make better decisions based on a tracking of data rather than just kind of guesstimating whether or not there's too much or enough humidity, for example, or that the temperature is warm enough or cool enough for my plants to have optimal growth. We started doing this in Bungoma in West Kenya. So this is data that's being collected there, just as you guys will be able to collect it in Nigeria. And that's really our goal, is to build an international data set, because it also allows us to track how we're doing in terms of sustainable agriculture, increasing yields of crops so that people are being fed locally, as well as being able to track data that can be useful for the global climate change initiatives coming out of the United Nations through the various accords. So this is kind of what your data ends up looking like, right? So you end up having this really nice graph that you can actually track from day to day, or in this case, you can even see every 12 hours, this data is being uploaded into this particular.
Heather, excuse me.
Yeah.
Your slides are not sliding.
They're not sliding because they're
no,
sliding for me.
Yeah, okay, they're not on
So
my
what are you
end.
looking at? Where are
I'm
you?
looking at your first slide.
Still? Oh,
Yeah.
wow. Thanks.
Yeah.
Okay, that's interesting. Because I'm looking at slides that are changing place. Okay.
We
let
see
me
your
edit
cursor
that.
moving, but it's like, okay, now they are.
Now they are.
Yeah. Oh, can you see them as slides, or are you seeing my notes?
As
seeing your notes.
not as a slideshow.
Right,
Yeah.
but just
we see everything.
so it didn't present. Okay, that's fine. We'll stay with this. So here, just so that you guys know what I was talking about that you didn't see, here's a greenhouse. This is out of the French property that we're currently providing sensors to. Here are sensors that they've got in that green circle with the white arrow pointing at them. They're collecting, those sensors are collecting data. They have two different sensors because there are multiple different kinds of sensors, and we'll talk more about that. But they're collecting data on that greenhouse to ensure that the conditions of that greenhouse are optimal for the plants that they're growing there. And this is what they're looking at. So this is what the platform for our data analysis looks like. And you can see, you can actually follow this graph. In this case, the data is uploading every 12 hours. So every 12 hours, they can look at another data point and see what's going on here. And I'm going to say that one of these things, at least, is probably looking at ambient light. And so ambient light, right? So this would be a midnight reading. This would be a midday reading. You can see how light is changing and being measured, maybe a full moon night, right? And so that they can also track, like, are the plants getting enough light? Okay, so there's a lot of information that we can collect with agricultural sensors, and it's easy to access. These particular sensors that your kids are going to be building can be read on this type of computer data platform, but can also be read off the data of an iPhone or any cell phone. They actually have a Bluetooth connection so that you can read it off your phone. The heart of where we ended up with sensors is because we started off in sustainable agriculture. So we have an entire program through Open that looks at how do we develop and rebuild and have better soil and maintain better soil practices so that we have abundant crops. And we've been able to have, this is from our Kenya farms that we work with. They've been able to increase crop output by as much as 10%, which is pretty good. When you figure we're not doing a whole lot, we're not having them buy fertilizer, we're not having them do heavy tilling, we're having them set up their fields in a sustainable way, and then growing their crops through a series of seasons, growing seasons, where we slowly improve the quality of their soil and then see this really generous benefit in terms of crop output. All right, so sensors. Sensors are an opportunity not just for data collection and feeding in and being able to make these kinds of decisions. It's also a huge, booming, growing sector of industry. In the senior secondary school guidelines, in Nigeria. You've got guidelines that talk about setting up electrical shops and radio shops and television shops. Someday, you're also going to be having, how do you set up sensor shops, shops where people are building sensors, building the cases that the sensors go into, installing them and maintaining them out in the fields, and potentially also serving as sort of a central data location site where they can collect the data and then analyze it out to the local farmers and have that conversation about how do we deal with the floods, how do we deal with what's going on with our aquifers underneath the ground and replenishing those water sources. And what we are hoping is that your kids, like these kids from one of our New York schools, will be building these sensors that can be used in their communities, and that they'll be those initial entrepreneurs starting the sensor industry for your country. So I'm probably talking too fast because I think I've got a while to go before we get to tea. So let's talk for a minute about questions. Any questions about sensors or sensor deployment in Nigeria?
It would be interesting to know, because some of the communities where the teachers came from are farming communities, like Kuje, Kwali, even us at the foundation, we have interests in trying to get farmland so that we can do this, this project there and have the children work with sensors there. It would be good to hear from the audience. How is the farming community? How is the yield from the farms? What are the needs? Generally, the population of Nigeria is increasing, and it is projected that by the year 2050, it would have doubled. We're already over 200, some say even 250 million. So once that population doubles by year 2050, that's less than 30 years away. How are we going to feed them? Which is part of the essence why this is so apt, as it's so practical, as a way of helping us have higher yield. Yep. So let's hear from them so that they also have to make connection with their own needs in that community for how this is going to impact their lives. So I'll be interested in hearing from them.
Thank you, Ms. Eda, for that presentation.
Well, it's the first part. We're not done.
All right.
Pause. Let's talk.
Thank you. Yes. And over to the class. Do we have any questions? Any reactions to the presentation?
Good morning, everyone. I'm Mrs. Adejugbe-Williams from Royal School of Educational Therapy. Thank you, Ms. Ida, for that. Like a few days ago, I was going through the news on my phone, and it says the president said a lot is happening in Nigeria with the poverty rate and everything, that because he wants everybody to go back to the farm. So hearing this now is like, thank God I have a way out of this. From what you said earlier, you said the sensors would be used for pressure, humidity, temperature, gas resistance, and some other things. Okay, now I don't know, is it the sensor itself? Basically, we've not, I'm assuming I've not seen the toolkit. I don't want to be like an RSSer, but I want to know, these sensors, can they just be placed anywhere?
Yeah, so the sensors can be placed on, so some of the images that I showed you up here, right? Here we've got a sensor that's basically planted in the middle of a crop field. And in this image here, you've got one that's hanging off of poles in a greenhouse. We will later see images of sensors that are attached to the log, like the stump of a tree. So where they can be placed is very flexible. You could put them on the side of a building. You can put them on a pole in the middle of a field. So they're very flexible in terms of where they can be located. The one catches, right, is you'll notice these are in cases, right? So the second phase of this project is actually to do 3D printing of weatherproof casing that the sensors can go in. And once they're in a weatherproof casing, then where they're located is very flexible. That's a great question.
Thank you. In the meantime, we distributed some sticky notes so that we can have a very fast collation of the questions or reactions. Do we have any question? Okay, please.
Good morning, all. The question I want to ask is that, can it be used, since we're talking about farming, can it include poultry, or is just restricted to greenhouse only?
No, I would say that it could be used for really any agricultural or non-agricultural. I mean, some of our sensors are actually being used to monitor air quality around the volcanoes in Congo, to see if we can use measurements of CO2 levels as a way of predicting what's going on with the volcano. So they're very flexible. So if concerns around like your poultry practice is it humid or too humid for our chickens? Do they need, is it warm enough or too cool? It absolutely would be applicable in that use as well.
Good morning, everybody. My name is John Olubenga. Can it be properly analyzed and defined, for proper understanding?
Yes.
Hello, my name is, are you hearing me?
I'm hearing you. You're asking about the data collection piece of it and how it's collected and then how it's authenticated, correct?
Can I come back with my question?
Yeah.
I said, can it be properly analyzed, as in different fields, the sensors, the advantage in social area, in agricultural, in this and that? Can it be properly analyzed so we can get it properly?
Okay, so properly, meaning the use of sensors or the practice?
Yeah, the advantages of it. Yeah.
Yeah. So that actually is an ongoing practice. Sensors are broadly used in many parts of the world already. They're broadly used in the American agricultural practices as well as in China. So we do have some good source and base data that supports the use of sensors, and that this data collection that we can get out of them can be very practical and helpful in making decisions. An example that I can give you is I'm here in Massachusetts, United States. Harvard University manages a local forest here where they're tracking and collecting data and trying to determine the impact as our climate is changing on that forest growth. And they're using sensors that are both placed up in the tree canopy and also at the base of the trees to monitor sort of shifts in average temperature ranges, humidity levels, CO2 being both absorbed by the forest and also produced by the forest. And so yes, sensors are being widely used, and it's really sort of a practice that moving forward is a common one. It's just one of the reasons why these kits were developed, was because we've reached a point in sensor use where trying to get it out to more parts of the world than just the areas where they're established now is really a big objective. I hope that answers your question.
Yeah, if I could also add, we're talking to a plantation owner out in Hawaii who is growing cocoa plants, and they have water issues there. The plants, if they dry out, they really don't do well. So they really have to track, and they have a soil moisture and temperature sensor in the ground because they've been overwatering, because they don't want it to get dry, but they had no indication underground what's really going on other than, identifying when the plant was getting unhealthy. So they're getting precise readings now from what the soil moisture is, so they don't waste water. and they properly water the plant so it grows better. So, I mean, there's just a multitude of applications, and other ones are in pollution monitoring in cities for air quality. And that's one of the pieces you're going to be building out of this kit as well this week, that can monitor the temperature, humidity, barometric pressure, but also monitor air quality, in particulates levels in the atmosphere. So they can be used in the city, in forests, in industry. There's just a ton of uses that this kit alone could do. We're focusing on agriculture because it's something we are focusing on for the other side of our curriculum. So we're applying it in agricultural to grow more crops, get more yield and get more precise information so the farmers could make the appropriate decisions as their plants go through the growing season.
Also, if I may also add something that's really very practical right now that I am experiencing. Some friends and some people came from Canada to Abuja, actually. They're targeting Abuja, Benue, and also some other states in the north to grow moringa. They had huge expectations that they were going to be able to, everybody should grow like an hectare of 1 hectare, each participant get an hectare, grow moringa in it. And at the end of the yield, which they say every 3 months, that we will be able to harvest, they will dry and export the moringa to Canada. Big expectation. All of us were thinking this is the solution to our financial situation, because they were promising to pay $5,000 every single month, right? So we grew the moringa, and the thing is at a big loss right now. We grew the moringa, and for some reason or the other, they were not growing because they brought particular seeds. They were not growing as they should, and those that grew were drying out within weeks of having germinated. So that became a big problem. So we're like, what was causing it for that particular brand of moringa? So we need to kind of do some research, some analysis. So what I thought about immediately was sensor kits to guide us. So if we had that at that particular time, it would have been able to help us in making determination that, okay, because the people were like, you don't need to water moringa, this and that. We would have been able to gauge it ourselves and probably have better results now. So that is the value that I see in us getting into this. Remember, farmers are going to need this. They don't know it yet, but it can have tremendous value to their output.
Thank you, Dr. Badewa. We have about 3 questions that have been sent in, and I would like to read it out.
Yes, please.
All right. So Mr. Joel is asking, can this sensor be applied with local farmers? And what are the benefits or advantages to the farmers in the local areas?
That's pointed at me. The advantages are making better decisions per crop and increasing yield by the data that you're going to be getting from the soil, whether it's soil fertility levels, because we want to increase soil fertility. Am I hearing an echo there? Yeah. We can monitor with one of those sensors what's happening underground, which, as Heather had mentioned earlier, they're just guessing a lot of times. I mean, farmers really get to know their own land, but the soils have been degraded. There's erosion issues. How do we do it better? And it's a combination. It's not just just throwing a sensor in there. It's actually, how do we regenerate the soil? How do we protect against erosion? And that's physical as well as getting the data out of an electronic device. So if you combine good practices in agriculture, and that's what we did first in Kenya, and we got triple the yield just by increasing the soil fertility by adding crop waste and mixing it up with we first did sweet potatoes. And this is just the students doing this and putting the layers of diked plots, which kept the rainfall from eroding the topsoil. So we increased the fertility level while we retained the soil, the topsoil, which is so important for the plants. And we got triple the yield over normal crop growth that season. And we did it 3 seasons in a row by the students. That's when we got the attention of the Ministry of Agriculture there, who want to expand the program. Now we got the data from some of these analog sensors. Now we're going to get more precise, timely data from electronic sensors, which can send it through the internet to your cell phone or your desktop. So the farmer can, on his own or her own, make the decisions appropriate for the plant and the season and what's happening to the environment. So you have all this information, but how do you sort it out? Well, we're going to try to help you do that, because we're going to have courses on analyzing the data that go along with the sensors. And then the farmer will learn this too. So we're going to teach the farmers along with the students. This is what we're doing in Kenya and in Liberia and other countries. And we're going to hopefully do it in Nigeria. But your students will be leading the way with these new kits that can add more value to the farmer's knowledge. So, you know, we think it's a combination of really smart practices, sustainable practices, regenerating soils, along with better data and information from what's going on underground and in the atmosphere. I hope that answers the question.
Thank you very much. Mr. John Olugbenga from Abuja 30 is asking, can it be properly analyzed, the advantage on each crop and how to make use of them? I repeat, yes. Can it be properly analyzed, the advantage of each crop and how to make use of them?
So what we're starting with is collecting the data. There is already data collected about many crops that will be able to apply to it, but you're going to have some crops in Nigeria where we'll get to do science, right? And do that analysis and say, okay, so we collected this data and how did our crop do this year? And so based on what we're looking at, do we think maybe we should have watered at this time? You know, so it's going to be, there's an aspect of science that can certainly be integrated here, which aligns with your agricultural practices standards in your Nigerian education curriculum. So this is just another tool in addition to saying what we teach now, which might be to go out and take a handful of the soil, and if it still sticks together, it's too soon to plant. But if it's, you know, crumbly so that there's air for the roots, it's time to plant. Now we can even add to that and say, okay, so what is the actual moisture content of that soil? And the sensor can tell us that. And so now we've just got another piece of more precise data. I used an example with my students of saying, you know, when the Olympics were first run in the 1920s, you know, the way that you knew that the winner of the swimming match had won was somebody was standing at the edge of the pool and looked down and watched them touch the wall. Now they touch a touchpad, and in a millionth of a second, which is much faster than my ability to see that you're touching and to say they touched, that they have touched the side of the wall. That's what sensors do for farmers also. It takes us from sort of what we can observe ourselves to just giving us more precise data about what we're seeing and what that can translate to, and then how we can predict it as well.
Thank you very much. Also, we have a question from Phoebe. The question goes thus: how many sensors do I need in a vast farmland?
George, what do you think in terms of
approximately
like
how many
acre?
sensors can be deployed into an hectare? Let's measure that with an hectare.
Okay. I mean, one, you can use as many sensors as you want, because again, the kit that you guys are working with can build up to 7 different sensors that are collecting different types of data. The particular sensor that we're going to be building with you is the environmental sensor, which collects 4 pieces of data, but there are also sensors in there that can collect ambient light. So how much sunlight is this field getting? Maybe I want to have one of those in different areas of the field because I'm wondering if I get too much shade on one end of my field compared to the other. So that, so there's a lot of different data that we can collect, and many of those can be different sensors. Do you want to add to that, George?
Yeah, I think the question they want to know is how many sensors would you need, like on an acre of land,
right,
or farmland, or on an hectare of farmland?
Right. Again, partly it's what questions are you asking, but George, what do you think?
Well, what we're doing in Kenya, and we're talking with the Ministry of Agriculture, is setting a mix of sensors per 2-acre plot, but we want to break them up by crops. So if you're growing sweet potatoes and bush beans, you probably want to monitor the same things in 2 fields. So we would measure the air temperature, humidity, barometric pressure. You'd measure the soil moisture and temperature. You measure the ambient light, and we're also measure the pH levels in the soil.
So that would be 4 sensors, 4 different sensors there.
Yep. Yep.
And then how many locations in that plot do you think you would have to have those sensors set up?
Probably just, 1 per each of those per hectare.
Okay.
Yeah. I mean, you don't need to blanket the fields with too many sensors, because you can get a general sense of the soil, the moisture, depending on the rainfall and depending on your irrigation system, on what and you can move these sensors around. It's not like that they're static, that you can't move them around, and cycle them through the field. So if you wanted to get if there was more light in one area and another, you'd probably want two light sensors, but and then see what the results are. Again, it's, as Heather said, it's science. This is pretty new stuff too. There is data, from U.S. farms and others that have been doing it for a while per crop, like corn or beans. So you'll be able to get that data. But your soils are different in Nigeria than they are in the Midwest U.S. So, it's a science experiment along with it. And again, you use the farmer's knowledge and you combine it with the knowledge that these sensors get you, and you're a little bit further ahead. It's not perfect information, nothing is, but at least you're incrementally gaining here.
And let's remember, the more data we collect, the more we know, because the broader the data set, the better the averages are going to be in terms of accuracy and predictability.
And the value of this is our students are actually going to be participating in the research, by building the sensors, and you test it at your school and let them give feedback. And this information we will need when they start their businesses to be able to communicate with the farmers. Because as we discussed earlier during our planning, that the way, like example, even the moringa, the way that particular moringa seed grew in Canada is completely different from the way it grew in Nigeria, because we have unique situations. Our soil is different. The quality of the rain that falls in Nigeria is different. You take some environmental factors into consideration.
But you might yeah, go ahead, Heather.
I was actually watching something just the other day where I was watching a show about growing grapes. And one of the things they said is that hours of daylight make a difference in what the outcome of the crop is, because in northern hemispheres, you end up with these much longer summer daylight hours, whereas if you're closer to the equator, it's pretty much a static 12 hours, and that can make a difference. That's an ambient light measurement. It could be that it's better for your plants that you're growing. It could be just that you're having a different yield or a different outcome than what you anticipated because of the amount of light that you're getting. So part of the fun of this, right, as scientists and science teachers, part of the fun of this is getting to have this be that big question to ask with your kids and then to go out and collect this information. And they're a part of that entire process because they're building the sensors that they're then using to collect the data to answer the question, how are my sweet potatoes growing in the school garden?
Yeah, and the comparative analysis part, just to close this up, the loop on this, is the cocoa plants that might, or the moringa that might grow better in Canada than it does in outside of Abuja, they may grow better or equal in Hawaii soil. So you might, as we do this globally in these different places where we're doing it, you might find that, you know, in one instance that a cocoa plant grows just the same in Hawaii as it would in the soils of Nigeria, whereas it doesn't in Canada or it doesn't in Australia. So we're going to get a lot of different data points and comparative analysis that the students could do globally. And we'll come up with some averages. You know, we'll come up with some information that's pretty universal, I would think, for certain crops in certain climate zones.
Thank you very much. Briefly, I would like us to quickly make a pause on our video. I would like to ask the in-class participants a simple question. Our next question, thank you very much, is from Mrs. Folade Rachel. She says, if you have a little farmland that you can practice this greenhouse, how can you be empowered in time for the equipment?
Okay, employed in, okay. So if you have a little farm, yep.
If you have a little farmland that you can practice this greenhouse,
yes.
How can you be empowered in time for the equipment?
So I would say if you have a little piece of land that you are already growing things on, then all you're waiting for now is the sensor to be deployed, which means built, put into some sort of housing container so it's not like getting rained and winded on, and then planted into your garden. It doesn't require that you have a power source for the sensor to work. Correct?
Well, the sensors. Well, we'll show you this a little bit later in the enclosure.
I want to repeat the question.
Yeah.
He's asking how fast can the sensors get to the farmers in Nigeria? We want to deploy this technology either from the manufacturers to the endpoint, which is the receivers, which are the farmers. Yes, what is the time frame for this equipment to arrive at the final destination?
Well, so if you're going with the STEM kits that you're going to be building, they get shipped from China to you. Right now, that's a bit of we don't know how long that will take because, you know, supply chain. Once it's in your hands, it's as long as it takes you to build the sensor, put it into some form of weatherproofing housing, and then to put it in the field.
Well, and network it.
And network it. But the networking really, if you look at the directions for it, it's, you know, you build the sensor, you put it in housing, you do the networking. It really is not that long in terms of time. It's what, maybe a day, 2 days, George?
Right.
Okay.
Depending on how like efficiently you are doing this. So.
Thank you. The next question, which you've already answered, says what are the source of the sensors, which is China. We know it's China.
Right. So this particular kit.
And check this question. Can we have it made locally? Is there a local production by the students, or can it be, you know, fabricated in Nigeria?
That is a good question. I think the only place where they're making these things right now is in China.
Right
but,
now,
you know,
the only place that right, George?
Yeah.
Like I'm pretty sure let's remember why is a lot of technology coming out of China right now, right? So one, the Chinese government has been very generous in funding this industry and building it. And two, they already have the factories and the equipment to build it. Can it be done in Nigeria? I would say absolutely, but it's going to be a question of getting the funding and the permits to be able to build the kind of factory that these could be assembled in, like the equipment itself, the components of equipment could be built in, and getting the supplies for those components. So the various types of metal, the building of the chips, that kind of thing.
Yeah, it's a huge investment. And, some of the machines that make the chips are out of the Netherlands. And there was just a factory fire in the Netherlands in one of the chip making machine factories. So, it's a really concentrated industry right now. It's Taiwan, China, Korea, maybe Japan, a little bit in the US, some in Europe, but mostly China is the volume producer of this. And they have the machines that make the machines. Now, the kits that you're going to get and work with, you're assemblers. You're not making the actual chip. You're not sourcing in from the Congo the rare earth elements that go into those chips. So there's a whole network and supply chain of from resources in the ground to making these chips. But now we have it that we can assemble them so the students could actually build these things. You wouldn't be manufacturing these in Nigeria necessarily, although if the country wanted to and put billions of dollars into it, they could do it. But it would take that kind of investment in order for the government to be able to do this there. So assembly, programming, and there's unique programming aspects. Your students can be very creative with these things. You can come up with your own sensors. It's not, once you have all the piece parts, you can mix and match things and come up with something creative. And if your students can program, it's almost limitless of what you can do with these things.
Yeah, I see tremendous opportunity for us being on the ground level, be the first really in Nigeria to be trying things like this. And I think the only other place where they're using the sensors is Kenya and Liberia, right? In Africa.
Well, Australia.
In Africa.
In Africa. Yes,
in Africa.
right now
Okay,
in
so
Africa.
What George has been doing also is connecting us, my school with other schools around the world on how to make these things work. We actually got the sensor a couple of years ago, and because we had a little garden, and we're to use it to monitor because of issues with erosion and things like that in our school. We had not really delved into it fully as we would like to, which is what calls for this particular topic, because we're thinking if our students can benefit from it, if our students can benefit from it, let's learn more about it and let's learn how to integrate it, because it has all the components of STEM so that it becomes for a reason. So we're all going to be learning together. We're all going to be experimenting together, and there'll be opportunities for your students to work with other students from other schools. Yours may be the ones that would assemble, and maybe a couple who have the skills, like we said, some children with autism are really good at this. Maybe they would come up with the programming. Maybe they can. The next thing is once they can do this perfectly, the next thing is how can we teach them to program it? Or we work with other schools so that all those other students will learn the programming. We're just exploring STEM, in its entirety with these toolkits. So that's what I want us to get out of this, learning STEM just by assembling these toolkits.
The other thing that I would point out is, I'm sorry. The other thing I would point out is that you can form collaborations with your school and your local farmers, where you're providing the sensors and they're providing the crops and the soils that the kids are tracking the data on. And then now you've built a collaboration where kids also have those future relationships with their communities and having sort of that position of being somebody who knows something that people want to learn from them, which I think is a huge gift to any special needs kid.
Yeah, and I have to say that these kits the company that manufactures these kits that you're going to be using, this is brand new for schools. They are so excited. This is the Chinese company. No one, you're going to be leaders. Your schools would be leaders. Your special education schools in this new, technology use in the classroom for STEM and sensors. Sensors have been around a while, but they haven't been connected to the internet, and they haven't been broken into pieces for assembly and programming in a nice compact kit, which you can make like 20 different sensors. And we're going to be adding more different kinds of sensors as time goes on. So your kids are going to be learning these high-tech skills, and you're among the first to be using these kits out of China. So the companies over there are very excited about it, and are looking to you to see what's possible. So you're part of the grand experiment is what I wanted to say.
Thank you very much. We have 2 more questions. I guess we can take them.
Yes, absolutely. We've got 30 minutes till tea.
10 minutes, 30 minutes break.
30 minutes.
Okay, more questions coming in. We have 3. I'll take this question from Mrs. Shea from RSET Foundation. RSET Foundation. From your slides, you indicated the future careers and work. And that explains that there's a section for sales, repair, build, and building waterproof covers. Is that right?
Yeah,
the question goes thus. It says, do you mean what we will do tomorrow when you said build?
I'm sorry, Mr. Thompson, if you can hold the microphone maybe a little bit away from your mouth. It was hard to understand you.
Yeah, we're having difficulty hearing.
The audio, has been not good. So yeah, just keep the microphone a little bit back. I think we'll hear you better.
So can you repeat that last part of the question?
All right. When you said from your slides, you indicated the future careers and work. Can you hear me?
Yes.
And then you indicated there'll be some section for sales, repair, build. And when you indicated for build, you said building waterproof covers.
Yes, weather, yeah.
The question now goes thus. Do you mean what we will do tomorrow?
No. Tomorrow, you are just building the sensor itself.
And the second question says, does it need direct power supply or battery?
No, it does not.
Well, if you're going to put it in the field, it sure does.
Well, then.
Yeah.
Yes, it does.
Yeah. No, what the enclosures that you're going to be able to build, there's a program for a 3D printer to make the cases. So one school could get the 3D printer and make them for the other schools. And they're going to learn the skills of how to program a 3D printer and be a production unit for others. One of the other elements is a solar panel that goes on top of the enclosure, and a battery inside the enclosure, which is rechargeable. So the solar panel on the outside of the case will charge the battery continually. And this draws so little power that this sensor could last for years with that setup. And so the battery will retain the power. So when the sunny days come again, it will recharge. So yeah, you do need a power source, but it's very simple to set up and inexpensive.
Thank you very much. I have a question from Mr. Joseph, and he's saying, please, is the sensor multifunctional?
Yes.
Can the same sensor be used to determine the soil pH, relative humidity, and to improve the soil fertility? Thank you.
No. At this time, we do not have one sensor that can do all 3 of those things. It would take 2 sensors, one for the pH and one for the soil.
And one for the atmosphere. And you know, so
really, no, he said soil moisture and soil fertility.
Okay.
Right. So the soil one would probably be one sensor, and then one sensor that's doing pH, but right now, the only combination sensor we currently have is the one that can do temperature, humidity, barometric pressure, and air quality. The others are like one data point, pH, for example, soil, humidity, and temperature. That is a double. So soil moisture and temperature is one sensor, but it's no, yes.
Yeah, yes,
Yeah,
yes.
right, yeah. So, but that particular combination of pH, moisture, and soil fertility is not currently a single sensor. However, as George pointed out, that could be a future programming that one of your kids or kids that you're working with comes up with and creates a sensor that can do those things.
And we're actually pushing the sensor companies to do things they haven't done before with these sensors, like combinations that they just don't have. But it's what is available today. Heather's correct.
So for those two things, you'd need two sensors.
Okay, two sensors. If the sensor is programmed to be multifunctional.
Two sensors, one sensor that would be doing soil pH and one sensor that would be looking at soil moisture.
Okay, thank you very much for that.
And the one we're working with is going to do what?
So it does ambient or air temperature, air humidity, barometric pressure, so changing pressure for weather sensing, and air quality by measuring particulates.
So that's multifunctional. So you would get, and you will download the program, not tomorrow or this week. We're just going to be doing assembly and disassembly. The next step is downloading the software onto this kit by plugging it into the back of your computer, which the cables are there in the kits. And then the software is sent your way by the internet. And then you can load up that software to read all 4 of those parameters and get them on a dashboard or on a cell phone, so you can see what the the air temperature is, the humidity, barometric pressure, and then what's happening with the air quality. And you get them on different charts.
Okay.
Which is what I've got showing here, right? Like
I would like to make a little suggestion.
Yep.
Yeah.
Can we at this time show just a little demonstration, the STEM toolkit to the in-class participants? Can they see it at this time?
You mean the video of how to assemble it? I think we're getting ahead of ourselves.
We are, because that's supposed to be tomorrow.
Yeah, but what I want to draw our attention back to is our unique population of children that we're trying to teach.
Yes.
We were just using this toolkit as just a means of teaching them STEM, because it can be anything. It doesn't have to be this particular STEM toolkit. It can be anything whatsoever. But for the purpose of training, because we don't want to train just for the sake of training, we want to train for the purpose of looking forward to something for them to be able to do in the future, which is let them learn how to assemble this thing. It's new technology to us. That is where their ability level probably would be at this particular time. By the time we scale through this and you're able to teach your science standards, your technology, your engineering, your mathematics standard by just building this toolkit, then you explore other things. We are just saying this is a way for them to be able to actually have a career. It's not just STEM training for the sake of STEM training. It's STEM training for them to have a career. So that particular career right now that we're looking at is how can they assemble? Let's take it to the nitty gritty, just the assembling of the toolkit, just as a tool for learning STEM. That's what we're using it for now. The other components of it, let's perfect this first, and then we come back together and move on to the next stage. Now that they can build these things, what do we do next? You understand? So
thank you very much. We have about 2 more questions. This is coming from Rosalind. She's saying, how can the blind use the equipment?
So that's one of the questions that we're asking our specialists. I am hoping that as when I looked at the kit, that we can find some descriptors to help describe sort of like by touch, what's different about this particular piece of the kit as opposed to like this piece, right? We're also going to talk about setting up the workstation in such a way that it's always predictable where the correct piece is for the next stage, so that whether you're sight impaired or not, you know exactly that, you know, I'm always going to find this piece on this location of my workstation. So when we get into that sort of nitty gritty, that's part of what we're going to be having this conversation about tomorrow while we're actually interacting with the kits. And I'd encourage you to you know, think about that and discuss with your fellow members, you know, team members, how to best set things up so that all students are able to access.
Thank you very much. And the very last,
that is a good one. That's a good one. Yeah.
That's a very good question. Thank you very much. And the last question for the question and answer session is coming from Pauline, Miss Pauline from Kwali Junior Day Secondary School. She's asking, how many types of agricultural sensors is available? Can sensors be used to detect crop pests?
So at this point in time, these sensors would not detect pests, right? Because they're looking at more sort of atmosphere, soil, barometer, you know, temperature, humidity, that kind of thing, as opposed to whether or not we're actually seeing something crawl across the plant or whether or not the plant is infected with a virus or a fungus. I mean, that's still going to be in many cases, either a tactile or visual check of the plant. So at this point, no, I would guess though that there are sensors probably being designed to do that. Don't you think, George?
Well, one of the interesting in one of my working groups with IBM, there's a way to detect a certain beats of an insect from sound. I mean, really sensitive audio, where they can pick up, you know, this is just a regular insect that won't harm the plants, or this is a particular beat of a wing that indicates this is a type of moth that will eat holes in your plants. And so that there are different ways. One of the other ways that visual observation is very important, and you want to catch it early. And some of these moths first nest in trees. So in Liberia, they're looking at drone technology to go fly high above, near the farms, to see the trees and whether the moths are beginning to eat away at the tree, and soon they'll be down onto the fields. So using drone technology with cameras that are very precise, and even infrared cameras at night, you can pick up, you know, visually that you can't see necessarily what's going on. Where the insects might be too small, but they're eating away at the tree leaves, you can pick it up through other kinds of sensors that might fly on a drone. So pest management is a unique problem, and you know, that's how they're approaching it right now.
So not these sensors, but certainly, you know, the question that we're asking here, as Dr. Badewa reminded us, is can our students build these sensors? The truth is if they can build these sensors, then eventually they're probably going to be able to build a wider range of sensors, which could include the sensors that George is talking about now.
Yeah. I love these questions we're asking because we're thinking ahead.
Yeah.
And we're thinking about the value and potentials, you know, even as business people ourselves. When I was first introduced to this, I was thinking, how can we get a sole distributorship in Nigeria, you know, to distribute this? But now I'm thinking, no, let's give these children a chance at doing something. So as I keep saying, it's just a gadget that we're going to use to teach STEM to you on how to integrate STEM. That's it. That's all the thing about it for right now. So let's use this STEM toolkit to teach STEM integration. How do you integrate STEM? Well, let's practice. So this is the practical aspect of it by using the STEM toolkit. The advantage of this particular STEM toolkit is if our children can actually assemble them, then we can be ordering and they can be assembling. You know, when they leave your schools and they're looking for work to do, that could be at that point, and as a company that will hire them to come and be assembling this thing. STEM sensor kits, what is it called again? Sensor kits are gaining ground internationally. We should not be left out of it. No. So that's why we saw the advantage in it as using it as the tool to teach STEM integration. So
but I think the questions that they've asked that all of you have asked, I think have been great questions, because certainly the kids are going to ask questions like, why are we building this sensor? How is it going to be useful? And so asking these questions are important for being able to fill in that why this is something that's valuable to learn and to do. So I think that we've had a really great conversation here about the role of sensors and where agriculture is moving in the future, and how sensors are very much a part of what future agricultural practices will be doing.
Right. Very, very good, great questions, because we're all learning it for the first time.
Thank you very much. I think we have there are no longer questions on this end.
Great.
So over to you, Eda.
Well, so I know that we're early, but where I'm at in my slide deck is tea.
Oh no!
So if we'd like to go
because
a little bit early,
so fast. I was trying to.
I know I'm too fast. I'm so excited. I'm so excited to share this with everybody. So I'm sorry. I'll speak slower after tea.
Yeah.
Okay,
in the meantime, I'm happy to say if you want to take an early break, but I am going to set a challenge for you during this break. Okay, that will set you up for where we're going to go at the end of the second section of this slideshow, which is to cross the line between the schools and connect with teachers at other schools who are either, I know that when you introduced yourself on the first day, we have some science specialists, we have some math specialists, we have some teachers who specialize in various types of special needs kids' needs. Meeting their needs and educating them. So I'd like you to cross the line with the schools and find your fellow science teachers at other schools and sort of start talking about what we've talked about this morning in terms of how do you think this relates to your area or where your town is or your school is located in Nigeria, and kind of start that dialogue amongst yourselves.
All right. So, Mr. Thompson, we can take an early break. It is 10:48 right now, right? Mm-hmm. Your time?
So 10 minutes early.
Yeah, so we'll come back in 15 minutes.
In 15 minutes?
Well, how many minutes break do we have? It says 15 minutes on either side.
I think we changed it changed on the agenda to 20 or 30. I don't have an agenda in front of me.
That says 30 minutes.
Okay.
30 minutes.
So, okay, we'll come back then.
So we'll come back when? 20 minutes time?
Yeah, in 20 minutes time, yeah.
All right, thank you. So
sure.
We moved on to tea break.
But this is a good opportunity for them to start interacting and start discussions about this session. And I think once we come back, we need to still do a little recap to test our understanding of the advantages of this sensor kits.
So while the presentation was ongoing, some of our participants walked in, and
okay.
I don't know.
We can educate each other now.
Yes, so now's a good time to get each other caught up.
Yeah, so what we're trying to do is do a mix up. I know last days all schools sat together, so we'd like you to have a mix up so you can interact with possibly the maths teacher of a school should, meet with the maths teacher of another school and share ideas. Similarly, you do to all the subjects. So I think that is what we're trying to achieve. So
Correct.
please don't break, try and associate and have a new formation. Thank you very much.
All right.
Enjoy your tea break. Mr. George, your coffee. You need
I'm going to get more coffee.
All right.
Thank you.
Any questions, please that will be on every live. Just access it and write down the question.
You absolutely can continue.
Welcome back from a tea break. And also welcome back from the coffee break. All right, after the tea break, next on our agenda, we'll be discussing STEM leadership, teachers leading students, teachers leading with education opportunities. This session will be the presenter for this session will be Miss Eda Cowap. So over to you, Eda.
Thank you very much, Mr. Thompson. Welcome back, everybody. I hope you had you made some good connections with your fellow teachers, and that you found some future collaborators as we move forward in developing this program for your students, right? Jumped ahead a little bit there. So when we talk about leadership, I think that I know that you've been talking about leadership for the past 2 days. And I think that the piece to remember as teachers is that we have the ability to get kids to really believe in themselves. And that as a teacher, especially of special needs students who frequently have embraced what they're labeled by those who don't know them very well, how they're labeled by maybe people in their communities that aren't familiar with their abilities because they don't know them very well. It becomes even more important that we as educators provide that sort of environment that says, yes, you can do this, and lead them in that sort of building of confidence that they are capable. And that's one of the challenges that we need to think about, both in how we talk about science with these kids, with our kids, how we talk about technology and engineering, right? So if science is asking the basic question and looking for an answer in a way that is replicable and data evidence driven, engineering is then taking that information and making it into something that is usable, right? And then that becomes technology. And, math is a language that we're using in this. What we want to consider is, am I conveying to my students as their leader in this study that I believe they're capable of doing what we're putting forward here, that I believe they're able to ask great questions, that they're able to make observations of the world around them to come up with evidence-based answers, and that in introducing them to this idea that sensors are supplementing the way they can answer those questions, but also in talking about sensors as a part of technology, that if they've used a thermometer to say what the temperature is today, they're using technology, and a sensor is simply another form of that technology. I think is a really important inner work that we as educators always need to consider. When I am in a classroom, I always view my challenge is, how do I remove barriers to my students' understanding? How do I remove the barriers that they're running into? And all too often, the greatest barrier is my students' own belief about themselves and their mindset about their abilities and capabilities to learn. We have a tendency to say that scientists are just smart people. I used to use a slide of a toddler throwing a ball for a dog, and we use that as the basis of designing an experiment to show that science is not just some person wearing a white lab coat or having crazy white hair like Einstein, or coming up with 1,001 uses of peanuts like George Washington Carver did. It's really just about asking questions and then looking for really good answers and using the equipment, the technology, or making the equipment ourselves to be able to answer those questions. So Dr. Badewa used a great example of saying, you know, you can do science by taking a board, making it into a ramp, and then rolling various items down it and asking the question, like, how does this roll? Does it roll well? Like, how does it move down that ramp? Is a basic introduction to physics, right? Like how things move. And just saying, you know, those are good questions, right? There are no bad questions. The bad questions are the ones we don't ask. So, you know, we have an opportunity here of leading our kids and helping them be the innovators and the introductory group of bringing sensors to Nigeria and being a part of really building a whole new industry. That's a new industry around the world, right? It's not an industry that has multiple locations that everyone's using at this point. It's a growing and new industry. And so as a leadership, as educator leaders, this is your opportunity to really help your children recognize that they are capable and that they are a part of a whole new movement in science, because the data we're going to collect from these sensors is going to help us answer a whole lot more questions than some questions that maybe we've never even thought of asking because we didn't know how we would find the data to answer them. So it's a really exciting opportunity for all of us to be a part of this. So I'm going to pause and ask for questions.
Excuse me, Heather,
George?
if I could just interject there and kind of extend this a bit. You know, to differentiated learning and different students that you all have. And
we're going to talk about on Friday, just so you know.
Yeah, so. but really, you know, these students are going to really see how it's applied, and some of them are going to adapt to the technology better than others, or the programming better than others, or some might be just more interested in the business side of this. You know, like, what can we get out of this on a business basis? And you're going to be learning about an industry, which is the fastest growing industry in the world. So I think there's going to be enough here to really spread the wealth among your students. And that's the brilliance of STEM. And that's, I think, how these kits really can be used favorably for your students as well as in your teaching.
Absolutely. And some kids may just like setting them up in the farms and then making sure that everything's running okay. So, you know, I mean, there's something for everybody in this, and some kids may want to grow things, and their role in this industry is as users of the sensors. And but understanding what they are and how they work is going to make them a more a better consumer of sensor data and sensor usage as well. So, I mean, it's going to be, there are a lot of opportunities for everyone in this field, and it's exciting to be at the beginning of it and being a part of bringing it to your communities. So if there were any comments or questions, to give you an opportunity, And if there's anything that you thought that came out of the conversation at T that really sort of would be useful to add in at this point. And then we're going to start looking at some of your Nigerian frameworks. We're good? Okay. All right. So when I took a look at the appropriate standards that we can meet in this particular integration of sensor building and to some degree sensor utilization, right? I found that there were a number of topic areas. So we have your junior secondary education subjects. I also looked at senior education, secondary education subjects as a part of what could be useful. So for example, in basic science, one of the topics, theme 1, learning our environment, topic 2, environmental pollution, how sensors aid in tracking and quantifying different types of pollution. These particular sensors can pick up particulate data. And so you can actually collect data and then compare, do comparative analysis and look at how is our sensor picking up the particulates, what is it saying about air quality, and then compare it to other data points. In your basic technology strand, which is theme 1, understanding technology, topic 1, understanding technology, speaks to technology related occupations. Oh yeah, sensor building, sensor maintenance, sensor installation, sensor analysis, right? Like being part of the teams that maybe program and analyze the data that's coming out of the farms and then giving it back to the teacher, the farmers, right? Are all technology related occupations that come directly out of this particular topic area. And then being able to state the importance of technology. I think that sensors are definitely one of those. In your basic science and development, this is junior school standard year 3. Okay, so this is not just the first 2 I gave you were both year 1. This one's a year 3. They're looking for skill acquisition, meaning of skill acquisition, reasons for skill acquisition, decision-making importance of skill acquisition, how it improves quality of life and appreciates human capability. So we talked a fair amount about that this morning in terms of being able to talk about why sensors can really enhance and improve agricultural output. And then if I go into the secondary school levels, for those of you who might be teaching some of the older students, it related directly to the standards on essentially building small companies that were either electronics, television, or radio. All of those, how to set up a workshop. We'll be talking about sort of some of those aspects of it, but it's easily applicable to that. How to do the work, how to maintain the work, right? That's the question that we're asking is, can your students build these kits? If they can build these kits with practice and acquisition, they're going to know how to fix the kit because they've built it for the sensors. And that's really the foundation then of building a company or establishing an industry or having just a small workshop that is supporting a small community and the sensors that they're using. We're growing student opportunities with this project and with this opportunity of integrating STEM into your classrooms because it's an equitable learning opportunity. The term equitable has really begun to explode in education. We've been talking about inclusion and the need to include our special needs kids in achieving the expectations of our quote unquote regular kids over the past 8-10 years. And it's been a slow slog to get to a point where we actually have integrated classrooms. I know 2 of your schools are integrated and some of your schools are not. And the reason for really the foundation of why we want an inclusive classroom is to offer equitable learning opportunities, because we find too often we don't encourage, we don't believe, the kids don't believe that they're able to do what other kids are able to do. And that goes back to that leadership of we as teachers helping to feed and build that confidence in students themselves, that they are capable of being equitable, of being industry leaders in this case for Nigeria. It's including them in what's going to be a growing field. And as we've pointed out, and as George just pointed out, there are many aspects to this field. So there's something for everybody. There's something for the kid who just wants to manage a business, and there's something there for the kid who really likes the hands-on work of being out in the fields, of making sure that those sensors are installed correctly, checking on them to make sure that things are running correctly and maintaining them. Not just that you're going to have to be working in, I'm sorry, that would be the first train of the day here. Running by, if you can hear it, being a part of a growing field, right? And not only being a part of that, but maybe being leaders in it in many of the communities. This is going to feed future STEM jobs. We've already talked about the opportunity that kids may have of programming sensors to do what they can't do yet, right? Like that combination of being able to say, I have this one sensor and it's monitoring the fertilization of my field, it's monitoring the moisture in my soil, and it's also monitoring the pH levels, right? Like that would be a new sensor, right? That would be a future opportunity in terms of where sensors can go, which is pretty much wherever we can figure out and dream they can go. And then finally, as Dr. Badewa pointed out earlier, agriculture and sustainable agriculture is a foundational need for every country in this world. If we are going to have and be able to feed our populations, we need to have the agricultural industry that's going to be able to produce enough food, enough healthy food, and preferably food that's close to home, because the closer the food is, the more likely we are to be able to feed everybody, because if it's stuck on a tanker and it's like on the ground in the Suez Canal and not going anywhere, it's not feeding anybody. So we need our agricultural communities to be supported and to be developed and to be providing food for our local populations. And particularly, we know across Africa, this is a challenge in part because we're dealing with the real extremes of the impact of climate change with, massive droughts and floods and all of this going on. Being able to manage the soil in a way that allows it to trap and hold the water during heavier rain seasons, to replenish aquifers below it so that we have water available in drier seasons. We know that actually has been linked to sustainable agricultural practices. We've seen it happening in other parts of the world, such as Australia, Tanzania, the ability to actually bring back soil that can maintain itself in a much better way throughout the seasons is an important part of this. And sensors are part of being able to make that shift and manage our soils so that we have sustainable agricultural practices that are not going to, limit who can farm, and that are not going to require that you have a huge investment to be able to farm, but are going to be able to provide enough food for all of our populations, is going to really be a huge piece of the sensor industry. And hence the reason why we've started working with sensors coming out of our sustainable agricultural project that we do through Open. Any questions about the standards that I selected? Any additions to those that you think would be helpful, or that you think that you see alignment? right? Like these are the direct ones. There are lots of indirect ones also. Using science, which is the most integrative of all the subject areas, can also meet and push forward many of your standards around reading, reading comprehension, writing abilities, and also mathematics, because you can use all three of those practices as a part of the STEM work that you're doing. So it's important to know that it's not just these particular ones, but these are the ones that seem to most closely align if you were going to say, well, why should I be doing this lesson? Well, I'm covering these additional, which I may not be otherwise covering in other lessons where I'm focusing on, reading literature or writing essays or doing algebra, right? Or pre-algebra or basic math, depending upon your kids' abilities and level. So that was why I picked these. And then also you can argue that this is pre-vocational training, right? Because a vocation in the sensor industry would be an open field, because right now there's not much competition because there's not much of an industry. So building that industry makes it one that's really open and available for our students to be a part of right from the beginning, and therefore less likely to miss out on being a part of that. So are these some questions coming in, Mr. Thompson?
I think I would like to ask the teachers, how are they using the standards to guide their lessons, especially, in special education, because the standards are basic for everybody. So how do they integrate? How do they use the standards in their classrooms? I know we got the standards from a website, from the Nigerian Education Research Council website. So do they have access to the basic information that we had access to? Do they have the hard copies at their schools? How do they use the standards to guide their practices in the classrooms? I think this is a great point for us to have a discussion with the teachers. Let's hear from them how they are using the standards. Mr. Thompson, if you could anchor that, please.
Can they answer your question, Dr. Badewa?
Please, I would like for them to answer that question.
Okay, there's this curriculum from the NERDC for all levels, all cater the 9, I think the basic 9 level, right?
Yes.
She's asking if you have the copy in your schools. Do you have access to the copies? Have you seen it? Is that what you're working with at the moment? What curriculum do you use? Okay, the response I'm getting is that they are using the curriculum from ERC.
Education Resource Center?
Yes.
Okay.
And I think that is not the same as UBEB, right?
Well, Education Resource Center is a part of FCTA, Department of Education, but the ERC is national. Everybody should be using the national standards to guide their curriculum. So I haven't seen the ERC curriculum. The one I've seen is the one from the national. So how is it different?
Dr. Badewa.
Yes.
Please, for clarification, are we saying the ERC curriculum is the same as the NERDC curriculum?
I'm saying it should be the same because the national should guide what every state does. Yeah, in Nigeria, it should be. But as I said, I haven't seen the ERC. I've only seen the national. So it will be, maybe we can access it.
Maybe I can ask if they can see it, if they have access to it.
Mm-hmm. Yes, right? That would be a great question. Yes.
Yeah.
So each school, do you have access to the curriculum? ERC implements, sends to. So it's just a link. Okay, thank you. So Dr. Badewa, I think the understanding we have now is the curriculum is generated by NERDC, sent to ERC, and ERC is sent to the schools, to the various schools in FCT. So it's just a three-link connection.
Okay, based on their grade levels, the levels they teach, either it's elementary, primary, junior secondary school, or senior secondary school. I would like to know the focus for them on science, the focus on technology, the focus on engineering, and the focus on mathematics.
She wants to know the focus.
Can they have a mic to be able to, so I could hear them? Because I'm missing a lot of what they're saying.
Where's the second mic?
The reason I'm asking this is, we're integrating. So it's good for us to know how we can integrate these things where we put together a curriculum guide.
I would have suggested if this could be, assessed on the group work session, because these questions might need documentation and proper editing. I don't know.
Yeah, we'll be coming. We'll be coming back to this section when we do lesson plans, but right now we're just getting the foundation. How many and what standards do they currently access in their current curriculum?
So you just need a feedback. They don't necessarily have to go to the group work session.
Just feedback right now. What are they doing now? Right?
Yes.
What is the focus on science in the curriculum that ERC sends to you? What is the focus of science, mathematics, technology, basic science?
We should take the question.
Dr. Badewa, please could you repeat your question?
When you are teaching science, what are you focusing on? What content area? What are you teaching in science right now? Are you supposed to be teaching about the solar system, about life cycles or water cycles? I would just like to know.
All protocol duly observed. In mathematics, we have a scheme of work and likewise other subjects. Hello, are you hearing me, ma?
Yes, yes.
In mathematics, we have a scheme of work, and every time, like first time, there's a scheme of time. First time, there's a scheme of work. Second time, there's a scheme of work, and third time. So every time we have a, as in like this is the second time now. So the scheme of work for every week you have a topic that you will teach the students.
Okay.
So like for instance, in my class for last week is approximation in mathematics.
Okay.
I teach GS1. GS1 is approximation. This week we are in now is the open sentence. Open sentence.
Okay.
Next week will be like factorization. Upper week will be algebra expression. So that is how it is being planned till the end of the term.
Okay. What school are you with?
Okay. Abuja 30.
Abuja. Okay, it's an inclusive school.
Yeah.
Okay, now in your classroom, can you describe your population of students for me? What are their ability levels?
Yeah, in my class, class GS1, A, B, C. The A is like 75 students. That's Nigeria.
Okay. Yes, but okay, go ahead. The B.
And they are not even much in that area. The B class is the same thing. Let's just say 65. And likewise C. So it just depends on the schools and it's in a remote area. So you can't compare with the city and the other district because of the population.
Okay. Now, your type of children,
yes.
What is the mix Do you have gifted children? Do you have average students? Do you have low functioning students, or is it a combination?
Yes. There's gifted students. There are some that they are extraordinary, students. So we have them mixed together.
All right. So case for UDL, Heather. So when we start talking about universal design for learning for the lesson plan.
Yep.
Okay. Thank you. Thank you very much, sir.
Thank you. We have from Kwali.
Okay.
Good morning, everyone.
Good morning.
Yes. I want to talk on the science curriculum. Initially, you were asked what is the focus of the science curriculum, and I want to say one or two things on it. First, I want us to know that the science or this curriculum we're using recently, this 9-year continuous schooling curriculum, the science curriculum is an aggregate curriculum that is made up of 4 subjects, and that one we call it basic science and technology, which is made up of basic science, basic technology, PHE, and computer. And the focus of it is to develop the student skills, the process skills, and to ensure the holistic development of the learners and prepare them for science subject in higher studies. That is it.
Great. And what type of students do you have? And what is your population like?
Our school is a mixed school. It's an all-inclusive school.
Okay.
And the population actually is a major problem in Nigeria as far as Nigerian environment is concerned. We have about 80 students in a class, and we have just one is comprised of A, B, C, D, H, and just 3, A to H, just 3. That is it.
Wow. Okay. Let me ask a question. For your children with like a moderate intellectual disability, are they just left in the classroom, or are they pulled out at any particular time?
They are mixed together, doctor. They are mixed together, and they are doing very well. I will recall last time one of the students that got the highest score was visually impaired student in my class. That's just 3 B. So they are mixed together and they are doing very well. They are competing very well with their contemporary students. Thank you.
Thank you. That is a real the thing to push about inclusive education, about integration. So I really appreciate that answer. It answers a lot. And I want to also bring this point out. You know, when you talk about disabilities, you're talking about different forms of disabilities, and it seems like you've included them all. And I keep telling people, which is the value of actually having a purpose for this integration. I keep telling people, just because somebody is visually impaired doesn't mean that person is not intelligent. These are the potential people who would actually do very well with this technology. People who are hard of hearing, their intellect, their cognitive abilities could be superior to anybody else. So we need to stop discriminating and make sure we give them access to everything. So thank you for that answer. It pushes more as to the reason why we're doing this, so that everybody is given that opportunity. And I appreciate your school for doing that as well. Thank you. Any other school? Is there any school that deals specifically with just children with learning disabilities? I'd like to hear from them.
We have a school for the deaf.
Yeah, thank you for
yes, but that is not intellectual disability. I would like to hear from them, but I still want to hear from somebody that a school that deals specifically with intellectual disability solely. Go ahead, sir.
In our situation, we have students who are not too good academically. So what we do is we take them to a resource room. We have a specialist in the resource room who tries to help those category of children to meet up with the average standard expected of them. So basically, they are doing well. What they see, they tend to believe the more, and they are doing academically too. Yes.
Fantastic.
Our population is a bit lesser than the regular conventional schools. In our case, we have the most 35, sometimes a little less than that. Thank you.
Okay. Thank you. Thank you. All right. All right. Fantastic. Okay.
So right away, we have some more questions. I don't know, because while your presentation was going on, we asked the in-class participants to write out questions. Do you have enough time to take those questions now, or we'll do that later?
Nope, we can do some now.
Okay.
What did you say?
Let's do some now.
All right, thank you. So I'll begin with a question from Mr. Ayuade from the School for the Deaf. It says, my question is the sensor you are talking about. I do not know how it looks like. Can you clarify how the particular sensor can be of help to or benefit to the deaf students, because we desire for a more improvement and advantage? I repeat, my question is the sensor you are talking about, I did not know how it looks like. Can you clarify how the particular sensor can be of help or benefit to the deaf students, because we desire for a more improvement or advantage?
So we're going to be looking at the sensors tomorrow.
I'm sorry, we have the STEM toolkits there. All of them will go away with kits for their schools. So they have it, they'll see what it looks like. So go ahead, Heather.
Right, but what I was going to say is, I mean, the advantage to the deaf kids is the same advantage that we're offering all of the kids that are going to be touched by the teachers here today, who are going to go back to their schools with this skill set to share with their kids. So, you know, it doesn't matter what your disability is. If you have the ability to build sensors, if you have the ability to program them, if you have the ability to be a part of this industry, it's going to benefit you to be a part of this. So.
Thank you very much. This question is coming from Mr. Rabiu, School for the Blind. It says, is the subject in junior secondary school also the same with primary schools?
I found that there were some slight differences, and I think it's because you have a spiraling curriculum, which most national standards do, right? So we introduce a very basic level, and then we get a little more sophisticated as we move through the upper levels of school and prepare for the next level. So I don't have specifically what the primary ones are, because I did not look at primary, but if the primary basic science, I mean, basic science is ask a question and find answers supported by evidence. Sensors are about evidence, finding data that supports answers to questions. I think it would be very easily adapted to whatever the basic science or basic agriculture or technology topics are, even at the primary levels.
Yeah, I'd like to just follow up on that one. You know, all curriculum is supposed to be kind of like spiral. You learn to crawl before you can learn to walk, before you can learn to run. It's still mobility. So mathematics is mathematics. It's like in the beginning, you are doing basic addition, basic subtraction, and then you start doing the multiplication and then division. And then when you have to still put them all together by the time you are doing division. You understand? So curriculum spirals into the other. When you get into algebra, you are still going to add, you are still going to subtract, you are still going to multiply and divide. So that is the point she's making. When you start learning about life science, you start from the very, very basic, and then it gets more advanced as you progress in your grade. So yeah, some of this may sound alike because it's supposed to still have that foundation from the elementary age.
Thank you. Mr. Monday is asking a question about the sensors. He's saying, when you apply the sensors, does it have any effect on the deaf students negatively, or is it general students positively?
So sensors are simply a method of data collection. So I don't think that they have a positive or negative effect on students. Okay. The positive effect is that you've collected real-time data for a location that the kids know, if you're using it, for example, in a school garden, so that they can directly relate what that data looks like in their garden plot. So in that sense, I think, I don't think there's a negative impact. I think that there is a positive impact for all students, because all students do better when they can make a direct correlation between theory and practice.
Edda, please, we might have to go over the question again. I think this question is directed to the health effects.
Does it have a side effect?
No, it's a very low energy, it's not a high vibration. It doesn't make a noise. It doesn't make a light. It's a very unobtrusive type of sensor device. And it runs on very low power. And even the sharing of the data from the sensor is all run on like a Bluetooth type platform or a very low energy Wi-Fi. Correct, George?
Yeah. Yes, to the cellular system in your case, the signal would go to the data on the internet and then, anywhere in the world. But the energy output of this thing is not dangerous levels at all.
Thank you.
Thank you, because we're still trying to figure out the correlation between 5G and COVID.
Yeah, there is none.
No.
Conspiracy theory.
No, there is none.
Right.
Yeah.
There's a question from Mr. Victor from Abuja 30. In a situation where I have more than 2 hectares, it's a very large farmer. Is actually he has the farming in mind.
Awesome.
I have more than 2 hectares and with different crops planted in the same farmland. Mm-hmm. Does that mean I will get one sensor for each group, or how?
So ideally, we would say you would want one sensor for each different crop, and probably planted in the middle of that crop section of their hectare, at least for your initial data collection set, because each crop, as we were discussing earlier, may have different soil moisture needs, different ambient light needs, different temperatures where they are going to benefit the most. And so you would want to have that data specific for that crop. So let's say you have 2 hectares of land. Let's say you have 4 different crops that you grow on those 2 hectares. You'd want to have 4 sensors, 1 sensor for each crop.
And the last question, the blind learn by hearing, not by seeing.
Yeah.
We all know that their computer uses what they, sorry, I'm trying to.
That's okay.
Handwriting, I'm trying to pick it out. I'll take this again, please. I'll clarify and take it again. All right, let's take this one from Mrs. Pauline from Kwali. how can STEM subject be taught in a class of 80 students with just 2 visually impaired students? So we have 78 students and 2 visually impaired students. How can STEM subject be taught in a class of 80 students? I guess that's a lot of.
I mean, you know, okay. So we're going to dig a little deeper into sort of some of the pedagogy tricks of like UDL and differentiation. But I would say when I've managed my larger classes, I find that teaming students is very helpful. And if I have a visually impaired student that I can team with a maybe stronger visually non-impaired student, they can work together. And I find that it's good for both students. I like to tell my students, the one who's slowing you down, if you're a fast learner, is helping you learn more deeply. And the one who's slowing, you know, saying, wait, we need to do this again, is therefore really helping their faster students learn more, as well as learning themselves. So I find that peer-to-peer learning is a really powerful tool, especially when you're working with larger groups of students.
Excellent, Heather. And I think we touched upon this yesterday too during our presentation, when we were talking about the best ways for our children to learn, which is, you know, teaming them up or group work and doing projects. There was a time I was in Kaduna State. I was doing a presentation to the people at the Ministry of Education, and they posed the similar question that they have 80 students, and I'm telling them not to be writing on the board, right? They said, if you don't write on the board, how will they learn? I said, reading what you wrote on the board is not how they're going to learn. It's actually the practicalization of what you are teaching them. What you need to do is facilitate the learning to take place. They are responsible for their own learning. Yeah. All you do is facilitate. So it's the structure of your lesson, how you introduce your lesson, how you group them together based on ability level that will help them to learn. And then they said, won't that be wasting time? I said, if you take 20 minutes to do group work, that 20 minutes will save you 2 hours of explaining and re-explaining and re-explaining. Yes. So when Heather gets more into the universal design for learning, into differentiation, we'll expand more to give you more strategies on how you can make this effective when you have a big class. In the US, they don't have classes as big as 80 students, maybe at the universities, but in, you know, there's a class size regulation. I think it shouldn't be more than 35. I'm not sure. It's been a while since I've been out of the classroom. And when you are in a special day class, which is just for children with maybe learning disabilities, I believe it's not supposed to be more than 22 or 15. So, but in Nigeria, you know, we have more students than space. So the more we can get into a building, the better it is for our children, you know, but how do we make it effective?
I mean, I
so
would
they're
say
just
that,
not crowded and, you know, wasting time talking.
When I did team teaching with my classes, I found that the best ratio is if I had 3 non-special needs student to 1 special needs student, all 4 students had the most growth I've seen in learning. And so that seemed to be a very good ratio. So a team of 4, where it was kind of a 3-to-1 ratio, if you're able to do that, really led to amazing growth for all 4 children, not just for the child with the special needs.
Right. Yeah, that is good. Let me also just make one final comment on that. Some parents have said, well, I don't want my children mixing with those kids. And what I tend to tell them is those kids are the ones that are actually helping your child to become better. Because as it states, you know, when you learn, there's a saying that says, when you teach me, I may hear what you say, but when you involve me, I learn better. So when in the process of the child who doesn't have a disability or who is stronger, in the process of explaining to a child who has some needs, they are getting better at the skills. They're learning more. and they're becoming more proficient. So it actually also teaches them work skills, because when they go into real life, they'll be dealing with different types of people. And by dealing with different types of abilities in the classrooms, they are advancing themselves to become better employees or employers in the future, because they're already exposed to diversity. And that's what it is.
In the workspace is teaming. It's interdisciplinary, and this differentiated skills of a student that may be blind, who might be an amazing programmer, can do that part of the kit, where we'll have another group of kids that are really love to put things like Lego pieces together, which these kits are much like that. So, you know, you have, you know, that the workplace, it sort of replicates the workplace. What we're doing in the classroom in New York and in Australia, we're giving 4 kits for, say, 25 students. So again, we're trying to do about a 4 student to per kit teaming effort. So if we could work out that kind of ratio for you, I mean, that's more kits for 80 kids. But, you know, again, these kits can be taken apart, put back together again, and reused. You got to be careful about taking them apart, and you should package them well so that, you know, you keep it orderly and organized. But in the end of the day, this is a great, because it teaches different skill sets, and it applies to kids' different skills. So I think it can be more universal than a lot of different things.
Okay.
Thank you. We have one of our participants about to contribute to the same topic.
All right, talking about pairing the students in a large class, I want to give a practical example, like what I did last time, teaching students, visually impaired student and the normal student. I used to give them group assignment, go home and do this, browse, or you Google and then come, we do, that is for the next topic. And when we come, I discovered that the visually impaired student, they don't really contribute. And when you ask them, they will say they stay in the hostel, they don't have a phone that they can browse or this and that. So this time I devised another means. So in the classroom, I share them into group of 10. They all gather together in that lesson. And then I give them a topic, like I teach cultural and creative arts. So this time we're talking about music. So I give them what is music. They discuss among themselves. I see the visually impaired student too with their stylus, everything. They are also trying to write, because everybody must write something in his or her exercise book. Then I pick any student among them when we come back from the discussion session. When we come back, I pick any of the students and say, tell us what you and your group have in your notebook. What I wrote in my notebook may be different from another group. And I pick from each group, also asking the special, that is the visually impaired student, and they also give us contribution. Now they are carried along. They also learn now because they are working in group and they are also contributing in that group, not just left alone now. So I think that will help.
Fantastic answer. I really commend you, because that's the whole essence of different, you know, of grouping, of learning, of reinforcing learning. You know, as each group is describing, telling you what they've learned, others who didn't learn that will now learn it. So that is a perfect strategy to utilize in a class, especially in a big class, to make sure that everybody is carried along. Well done. I like that.
And I think that feeds to this idea of, as educators, we lead our students in believing that they are capable and they have something to contribute. And by providing a structure that allowed and created that greater contribution opportunity for your visually impaired students, you did exactly that for those students.
Good one.
Nicely
Thank
done.
you. Okay.
Thank you very much. We still have a couple of questions. There's one that says, the blind learn by hearing, not by seeing. We all know that their computer uses what they call JAWS. This is a software used to convert print to voice. So we all know that the computer uses what they call JAWS for them to hear. So how would this be beneficiary to the blind?
It's practical, isn't it? Since they're building. So they could be the ones to focus on the actual hands-on. I think they'll actually be stronger at this because that sense of tactile will be stronger as opposed to other people. So, I mean, it's perfect for them since they're going to be building and they're going to be touching to manipulate. And I'm sure they'll be adept at that. But if Heather has a superior answer, she may respond. But for me, that is the whole thing. We wanted something practical because of persons who may be visually impaired, you know, and this is a practical tool. So it's more advantageous for them, you know, because of their other limitations.
As I said, one of the first things that we're going to talk about when we start actually working with the kits tomorrow is the need to have sort of a set where the pieces go on the mat when you're building, so that no matter who it is, you always know that you're going to find this tool in this location on the mat. I think for someone who's visually impaired, you know, we know that you don't move the furniture around in the living room just because you feel like it, because then they walk into the sofa because they can't see that you moved it. So it's a similar kind of awareness that some things need to be sort of established in a regular sort of setup so that they know where the pieces are when they're working with it. But again, as we've pointed out before, just because you're visually impaired doesn't necessarily mean that there aren't other aspects of this industry that you might be extremely gifted at, like programming, because just as we can have word to text, you know, or text to voice, we can also have voice to text, and it's possible to program verbally because of those kinds of movements forward in innovations in technology.
Thank you very much. That implies they need a voice to text app, conversion app.
They already exist.
Yeah, it's on your phones.
It's on your Google Drive stuff. I mean, it's become extremely common to have a voice to text application available.
If you look on your phones, there is a little mic that you can touch to record, right? There's one that if you just press on it and you speak to it, it types it out. It's already existing on our phones today. There are two different types. There's the one you hold down and you record your voice, and is the audio, the voice message. There's another one that you record. It takes your words and converts it to text on the phone that everyone has right now.
Okay, and the very last question is from Mr. Monday, and is interested to encourage our students to take part in STEM. Well, when they get to the senior class, they will be pushed to the arts department. So what that means that from the period when they are in the junior arm, they study STEM, and by the time they transit to the senior classes, they are, because of whatever distinctions, and then they now separate them to art classes. I think that is the direction this question is taking. It now says that they lack knowledge of sciences. Is this the proper attitude to deaf students since they have interest for science? I don't know if you got that right.
That is the problem with our system in Nigeria. It's like you go to university, they force you to study something that other than what you've chosen. It's a problem in the system. The only way that we can change this right now has to be like on an individual basis. Like if you advocate for yourself, or if the parent advocates for the child, just because my child is hard of hearing doesn't mean that my child cannot see science and do science. Do you understand? They have to push for that. But it's a fundamental problem in the whole country. You know, understand, Heather and George are not privy to this. They don't know what goes on in Nigeria. When I was in school, I had a choice of choosing if I wanted to go into science courses in high school, or if I wanted to focus on art courses. I chose art because I was intimidated by science. I didn't understand science. And mathematics, oh my God, I ran away from it. When I now got to the university, I had a better understanding, right? And when I started teaching, I now actually felt like I should have studied science. I should have stayed in mathematics. So that is the advantage that you're having right now. You're teaching them these vocational skills now. So if, for instance, at the end of the day, they're pushed into art, what about their vocational skills? You don't always do what you study. Like you see people who went to school to study, maybe biology, and they end up working at the bank. So maybe they pushed you to go and study something other than what you're good at, but you still have that skill of what you're good at. So when you now become an adult in the workplace, you can go back to all these pre-vocational skills that you have and utilize that for your livelihood. So, it's a problem that it's not fixable by this training, but we can be proactive and make sure we give them the skills that will benefit them later in life.
Thank you very much. I just got a clue that Eda and George, you need to come to Nigeria. So I'll be inviting you in the next winter.
Okay, next winter
that sounds
lovely,
good to me.
Because I'll definitely trade the 5 inches of snow.
You wouldn't like our summer.
Too hot.
Thank you very much. The questions are over.
Okay,
and over to you, Eda.
Okay, all right. So when we think about this context of, and we bring in the standards because we know that as teachers, this is a responsibility we have to our students, is to integrate the standards and ensure that we're meeting those objectives for learning. And that's true of any student, right? So when we add sensors to this and we think about where do sensors in particular fit into that curriculum, we can talk about the science answering question part of them, but we can also talk about the mathematical piece, which is the data analysis. So you can collect data that looks similar to these two graphs as the graph that I showed you earlier. This upper graph is looking at, I'm sorry, can't read it myself, average percentage of sunshine. So this is looking at sunshine. Like how much daylight are you getting on a given day or over months, because we're looking at a January through December cycle here. And the lower one is looking at rainfall. These are both data points from Nigeria that I just pulled off of the internet for agricultural questions. You can track this, right, with your sensors, and then we can look at that average. And then you've got that opportunity to talk to kids about, well, this is clearly our dry season. This is clearly our wet season. Is this year following a typical trend or is it not? And we can graph that. So we can practice graphing skills. We can practice statistical analysis skills, finding the average, and we can do all that kind of thing. We can do this looking at one farm, just your local school plot data, and then you can also connect it and look at it and compare it to other parts of the world. So for example, you might want to compare this to Australia's data or to, Jamaica's data, just for the fun of looking at how different parts of the world are impacted differently at different times of the year and that sort of seasonal changes. These are obviously skills that we want our students to have, because moving forward as future agriculturalists and farmers or future sensor managers or future whatever, being able to do data analysis is a crucial part of almost every industry today. We do data analysis as teachers all the time when we look at assessments and then try to determine where are we having gaps in learning and where do we need to fill in the blanks and where are kids lagging, right? So data is really sort of become a language of the present, and it's an international language. And it's one reason why these become really useful, because that sensor feeds directly into the math class now, right? And this is where we talk about science as being this massively integrative subject area, because it requires reading and writing and mathematics. And so my point of showing this is just to reemphasize that your STEM can be integrated with your other subject areas, and vice versa. Like you could say, we're doing this big science project where we're building sensors and we're going to look at how they function in our, school garden. And as a part of that, we're meeting reading standards and we're meeting math standards, rather than always saying, well, I have to meet the math standards independent of an actual real life application use of it. This builds engagement for kids who struggle with, why do I have to do this? It gives a really resounding sort of why, and why is one of the key ways that we engage and motivate students. And also can build on that concept of grit, which is that ability to stick with something that's maybe not super interesting, maybe kind of boring, hard, so I have to just stick with it. Is if we have a big enough why, we can show that real life use of something, we're more likely to have kids struggle with that learning and gain that progress that we want to see them do in growth. All right, so what I wanted to do now was really talk about how do we fit this into your curriculum. So this is the big picture. This is not a specific lesson, but rather how do you see STEM fitting into your curriculum? So math teachers, so this is almost like a challenge to say, okay, math teachers, regardless of your school, go find other math teachers and think about, how can I use sensor data to move forward the math curriculum that we're teaching? How does this apply as a real life problem set maybe, or graphing practice that we could use in our classrooms? And then also topics that maybe you already have that STEM concepts and practices can add or expand so that they're more so, right? Like, that if I'm looking for reading comprehension of nonfiction, how can maybe looking at analysis of sensor data could be a part of that conversation, rather than just finding maybe an article on, well, actually, like finding an article on climate change, which is certainly a hot topic in more ways than one. That was not meant to be a pun. But that article now, you can really dig into, like, what's the data that they're using for that, and then relating it back to the fact that they're building the sensors that are collecting data that directly relates to that nonfiction article that you're reading for reading comprehension and reading growth. So questions? All right.
I want to add that agriculture really covers a range. The more we dive deep and pick agriculture apart, there's the water element, which is underground, it's hydrology, it's meteorology, it's climate science. There's so many different areas. And
soil science, it's microbes, it's microbiology when we get really into deep soil science.
Exactly. And so you're really, diving deep and splitting it into pieces where, certain students would really want to know, because water is so important in drought season, how can we really conserve water? Well, sensors can tell us all those pieces. It can tell us how the forest impacts the agriculture. We talked about the pests in the trees, but there's more to it. And what the tree roots do to the microbiology helps the farm. And we didn't learn this until, a couple of decades ago, exactly how important trees are to farms. So when we mowed down the forest, we weren't helping our farming. So now we can gather data on how do we reconstruct the agricultural whole system. It's going to take a few years, but at least now we have greater knowledge, and sensors will give us even greater knowledge about this. And your students will have many areas on which to focus, and you to apply it to the community, as well as to give them an understanding of, like, why am I studying agriculture in the first place? Why do I need sensors? There's a multitude of answers for this that you can now give your students and take them down different avenues that might really be a career generating.
So the challenge that I set for you is to get out of your seats, move around, find your similar subject area teachers. Answer these questions. You can put your notes into Post-it notes, or if you use this QR code, it will take you to a Jamboard that you can put your notes to. And then I will give you from now until lunch. So you're getting about 40 minutes to do this. And then after lunch, we'll come back and take a look at some of your answers and discuss, sort of how to get creative in implementing or integrating STEM more broadly across your curriculum.
And this also is a good point. Mr. Thompson, I don't know if you want to do this in the different groups. Maybe they can form different groups to actually tackle these questions together. I would like to, when they are in the group, I want to really know what their understanding is so far, based on everything that's been discussed from the beginning. And from that understanding, they can now start developing those questions. I mean, putting questions together about the STEM concepts and practices, and how the sensor could be a way to teach them in the classes. I think you guys are so comfortable sitting down. You need to get up.
I know. I'm watching. I'm watching everybody sitting there, and I'm like, so hello, people. Everybody who's a math teacher, raise your hand.
I can assure you, they are not sleeping.
I don't think they're sleeping. Everybody who's a math teacher, raise your hand.
This is so new. It will take a while.
We want to group.
All the math teachers go to the back left table. All right, and then you guys are going to all work together. I don't care what school you're at. You're just going to work at, like, how do we integrate STEM into math curriculum? Everyone who's a science teacher, you're going to go to, like, the front right table. You may have to bring some chairs with you. All right, so everyone who's a science subject area teacher, go to the front right table. You're going to do the same thing. All you're looking at is how do we talk more about technology and engineering in the science class, right? So that we're making it STEM, not just science. If we have any other subject areas, like if we've got some English teachers, yay, you for being here. Go find each other, go find a table, sit down, start talking about how can I use STEM in my English teaching.
And there was computer science, I think.
Computer science, absolutely. If you're a computer science specialist, yep.
Eda, please let us settle in our group sessions.
Fantastic.
Then we'll request you to come again with your instructions.
Yep.
Can they, after they settle in at their group tables, then you give the instructions.
Perfect.
Thank you. There's a lot of movement, and it's a little rowdy. Thank you.
I'm happy to see them moving.
Okay, you know what? This is what's going to happen. Let me have this. Sorry, help me pick that. If you need new markers, let me. Okay, that's what I'm saying. Yes, all of them. Please, we are setting things up.
Yep, that's fine. I think that's me though.
Just put you on one chair. We're almost ready.
Awesome.
I think we can also type the instructions on the chat. Is it possible, Eda?
It sure is.
So type your instructions or copy and paste it on the chat also.
Yep, that's what I'm doing right now.
Thank you.
Okay. It won't let me move copy over the QR code. That's the only thing. But the questions are there.
You need somebody to write.
I think if they want to use the QR code, they can go close to the screen, right?
Yeah. Yeah.
Let me see if I can use it too.
I tested it myself earlier and it worked. So.
Okay. If you're owning this QR code, visit your account page for more information. It has been disabled.
I probably have to open it. Maybe it's just limited or something. Let me go make it for everybody.
Okay.
Eda, how many questions do we have?
2 questions.
Number 1, how do you see STEM or STEM fitting into your classrooms? Somebody who teaches music could actually also include the art components to it.
Absolutely.
So how do you see STEM fitting into your classrooms? And then even everybody could even incorporate art because you all teach art, I would imagine, if you have, primary and junior secondary school. Then the second component, what opportunities to include STEM concepts and practices could be added to or could expand topics you are already covering in your classrooms now? Maybe we just take it one at a time.
Yep, one at a time.
Sorry, give us more time.
Yep. No. You get from now until lunch. All right, try this QR code. All right, cool. Great. Yep. Dr. B, I think this QR code should be correct.
We also urge the online participants to submit the responses on the chat. It's very important.
Yes, please. And if you are one of the online participants, using the QR code and joining in on the Jamboard will give you a chance to work with each other.
We are trying to create the breakout room session on the Zoom platform.
So if they want to on the Zoom platform, if they just jump into the Jamboard, and I'll put the link to the Jamboard in, they can actually just work together on the Jamboard and just post things as they come up with ideas as an option if the breakout rooms are a problem.
Mr. Thompson, I don't see many people on the on Zoom. Remember, people are working. I think it's just us on Zoom and a couple of others.
I think a couple of.
Because Mr. Ayade is on Zoom, but I think it's also there in person, isn't he?
So I think Dr. Badewa.
Yes.
I'm going to add you, George, and Eda in one group.
Okay.
Okay.
So maybe you can give us a superior version.
Eda and George, you just go for it.
That is my challenge.
Okay. All right. So what group are we in?
Oh, I guess we can pick any room we want.
I don't know if he's doing it.
It's saying unassigned, and then there are 4 teams, but they're all empty.
Yeah, that's what okay, so should we be team A?
Sure, let's be team A. A
Okay.
for, well,
Okay, I'm joining team A.
I am joining team A.
Okay, you are there. Where am I? Every time I click, okay, yes. All right.
I guess we were able to make out 3 groups. There was a group for maths. The second group was on science, and the third was agriculture.
Great.
Yes, math, science, and agriculture. Are we ready?
Yep. So math team, do you have anything to share?
I think the food is still processing.
Maybe we really need to stop eating. Food is STEM, you know, so it's okay.
Let us who is coming? Who is the first presenter? The group? Science. Okay, thank you. I need someone to come first. Let me introduce you now. Look at the camera. Mr. Shegun will be my co-anchor for the afternoon session. Say hi to George.
Hello.
Hi,
Thank
hi.
you for helping him out.
I'll be taking some rest after now. Like 2 in a group. Somebody should just come by and stand
Heather,
by.
can you screen share?
I sure
Maybe
can.
we'll see their screen better. Oop.
Yeah, if they can, like,
Everyone in the group
showcase.
come and support him.
Spotlight.
Yeah.
There we go.
Yeah, I think just 2 persons should stay.
So we're going to call out 2 presenters for each group.
Perfect.
One will make a presentation, and I guess the other should be willing to respond to any question from online and in class. us your name, the school. Take such a group.
Are we set? Okay. Good day, everyone. My name is Rabiu Gani Oluwakemi. The group is on now.
We can hear you.
Thank you. The group, our group is science group, basic technology, basic science, and other science groups. So the first question, how can STEM fit into science classroom? Am I correct? How do you see STEM fitting into your classrooms? Great. As we all know, science deals with critical thinking and project analysis. And so STEM will easily fit into the science class in the following ways. I will mention some of them anyway. One, science is learner-centered. Unlike other subjects where a teacher can come to the class, do a radio presentation, stuff of blah, 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 and go. In science, it is more of learners-based, it's learner-centered. You need to allow learners to be involved. And so STEM will easily fit into this particular subject called science. Thank you. Secondly, science involves problem solving. STEM, from all analysis we've had since this morning, is also about problem solving. And so it won't be difficult for STEM to fit into science because we're trying to solve a problem. Ideally, number three, it is more of a project-based. Science is project-based because in a class of science, you need to group your students, you need to group them into maybe groups and give them a project or a task to carry out. And so this is more of what STEM is telling us here. And so STEM will easily find its base here. And another point is it involves creative thinking. It involves critical thinking or creative analysis. You don't just come to the class and start blah, blah, blah in a science class. You have to give reasons why this is this and why this is so. And so STEM will fit in practically here. That answers question one. Question two, what opportunities to include STEM concepts and practices could be added to or could expand topics you're already covering in your classrooms now? Yes, this is very interesting. It is more of simple to complex. Question one is leading us into answering questions two. Why am I saying this? In skills learners who are familiar with science can always and will always improvise using instructional materials. Sometimes in a science class, you need to improvise what you need. When you are teaching, it is not every time you have money to go and buy a television, go and buy this, buy this.
Your microphone has gone off again.
Yeah. We can hear you.
Okay, now go ahead.
There you go. Nope. There you go.
Sorry about that.
No, that's okay.
What I was trying to say is learners can improvise instructional materials they need to use in a science class. And so if you want to teach maybe communication, for instance, or ICT, you can ask children in your class or students to improvise, use matches or local distance, twine, connect one to another so that you get information across through a source. In science, it is practicable, it is possible. So learners could use this to learn more in STEM. Secondly, it gives room for skills acquisition. In STEM now, we have been told practically today that you could be a teacher and as well be a farmer. You can get a small portion of land and use what we have learned today to practicalize farming and get your results and help your family to feed. Majorly in Nigeria of nowadays, food is a problem for every home. So you can do some small farming using STEM as practically as possible. Ideally, number 3, I said it gives learners opportunities to hands-on activities. What do I mean here? You make use of your hands. In most of the activities in science, it is not something you sit down and use theory. You practicalize. You use your hands to figure out what instructions you want to pass in or you pass across. And much more importantly, it leads to critical thinking among learners. If you group your students into maybe groups, you tend to allow them make use of their reasoning faculty. Then they think, what is this man? What does he want us to come out with? So students make use of their critical thinking through this, and so brings out the best in them. Thank you very much. I don't know whether I've spoken well.
Nope. Nice job. And
very nice
excellent points. Thank you. That was great. That was, you had some really good points.
Do they have questions from their colleagues?
Here? Do you have any questions here? Okay. I don't think we have any here. I don't know.
Okay, well done, guys. So next group.
Thank you.
Okay, next is mathematics.
I bet that's the biggest group.
Yeah, I think it was.
Good afternoon, everyone.
Good afternoon.
We are from the mathematics class. Yeah. So we just go straight to answering the question that was posed to us. How do you see STEM fitting into your classroom? That's interesting. We brainstormed and looked at so many topics that we mathematics in our schools. And now we quickly went to look at shapes. Let's say we are dealing with shapes. So we present ourselves with the shape of a rectangle here. In this way, the length is given, the breadth is given here. The length is 5 centimeters, the breadth here is 2 centimeters. Now,
good.
Okay, now, in order to guide our learners to solve this problem that has been posed to them, they were already asked to find the perimeter of this shape. You have to find the perimeter. Now, ordinarily, we know that a perimeter is the total length of the figure around a shape. So now, for them to add 5 plus 2 and go in that order, there will be no need at all. We have to engage them. We need to stimulate their interest. Therefore, we can present a physical shape. Not only this, though this might be on the whiteboard, a physical shape, okay. You can ask a learner, come, measure this rectangle for us using your ruler. Now, one of them will come out, measure the length. We'll call another, measure the breadth. Then the second length, another learner in that order. The 4 of them will come out. What was your measurement? Learner A, he will tell us it's 5 centimeters. Learner B, what was your measurement? 2 centimeters. Learner C, 5 centimeters. Learner D, 2 centimeters. Ngwanu, sum them together. I don't speak my local dialect too. So, so then the 4 of them together, we come together to add all the sides. You see, you have engaged them. So you have already stimulated their interest. And when these learners go back, you discover that they may even go back and be practicing this. I did this in the class today. And the result of what they put together will be what? You can ask them. That is the perimeter. That will be the response. That's the expected response. That will be the perimeter, sorry. So you can see that STEM will really fit in while teaching mathematics in your class. That is one. We quickly now move to question 2. We look at the question here. What opportunities to include STEM? We also brainstorm here. What does this question want us to really do? All the members in the team, they look at opportunities. And so one of us came up and said, what we are looking for here is gap. That's what all of us agree. Yes, it's true, it's gap we are looking for. What is the gap that is found? Why teaching mathematics in your classroom that you want to bring in STEM to close that gap? We say, okay, we agree. We'll not go far, we'll still go back to measurement. One of us suggested that let us engage our learners to measure farms. Maybe primary 1, 2, 3 have different, they have their own different farms. Then their demonstration farm in the school there. Why don't they go there? Another group say, no, there's no point going out now. Since we don't have much time, why not measure the classroom? So we decided to draw this hall here. Actually, it's a classroom. And if you observe in mathematics, most time if you are looking for the length or breadth of a shape, it will be given. If you check all through your textbook there, it will be given. It's left for you now to either sum or multiply. So in our own case, we say, no, we are not going to give you figure. Let the learners take the measurement themselves. So in the case of the classroom, you take a learner A. We ask him now to measure the breadth of that classroom using their foot. So you now use your foot to measure. You count. You count 1, 2, 3 in that order. Assuming we get 22 centimeters. So we now record it against this as 22. So also it will be done in the other side of the shape. That is the classroom now. You will see that you have engaged them. You have stimulated their interest. And you know that learners, especially the junior primary, they are playful. They like to play. And if you don't engage them, the class will be boring for them, for you. And it will be boring and the interest will not be there. So as they are engaged, taking this measurement, moving up and down, you are already engaging them. So they are active in the class, their interest limited and all of that. So you can see that there is a gap, especially in this, in finding length and breadth of figure of shapes that are already given in the textbook. In our case, we don't want to give you a figure. Use your figure yourself, measure it using your foot, after which you come together and sum and then get the result of the perimeter of that classroom. That was what we were able to do in our class in mathematics.
Awesome. I'm glad that you translated 22 centimeters to being 22 foot, because I was thinking that's a really small classroom.
Yes, you have different different height of learners now.
Yes.
There are some learners who are tall, there are some who are short. In this case, we pick a short learner.
Yes, yes, very short.
We also find out that the visual impaired or those physical challenge people can also fit in STEM by the use of calculations.
We also find out that we can also use this measurement to teach those. For example, in our school, we have a blind student who cannot see, but they can also fit in STEM. One of the practical measure we use is they can use their handspan measurement, measure the length, measure the breadth. Now, for example, you can ask a student, physical challenge student, to find the perimeter of a rectangle, 5 length, breadth, and 10 centimeter length. What the child needs to do is to use each handspan represent 1 centimeter. So you go 5 in the breadth, you go 10 in the length. Do it round, 5 this side, 5 this side, 10 this side, 10 this side. You now ask the child to add all of them together. This physical challenge person, at the end, what the result he or she gets, is what we call the perimeter of that shape. So they can still fit in, whether physical challenge or active students. Thank you.
Yeah, that's great. I like that.
We await your questions. Do you have any questions, please? May we also remind you that those of us in the special education are advocating that students with visual impairment should be exempted writing external examination in mathematics. So that was why we brought this.
This is a great exercise, actually, because I've used this so many times. The inquiry learning aspect of it is when you give them the measurements on one side, now let them look at that shape, the top and the bottom. Let them make a comparison. So they will realize that if it's 10 on top, then at the bottom would also be 10. So that's your discovery learning right there. So that is a great strategy that you just used to illustrate teaching STEM in mathematics. Yeah. Good.
And of course, a lot of farms are rectangles too. Not all of them, but again, it's taking it from the indoor to the outdoor and whatever we can apply it to that's meaningful to the students. And that translates.
Yeah. Excellent.
One more group, correct? Agriculture?
One more group, please. Agriculture.
Good afternoon, all. Yeah, to talk about how do STEM fit? How do you teach STEM fitting in agriculture in the classroom? STEM can fit in our classroom into the following ways. One, it introduces agriculture into new technology. For the 20th, 21st century, we have been farming agriculture manually. People go to farm, use cutlass, and use hand to weed grasses. But today, we have herbicide, we have insecticide that can control weed. You don't need to use your manual labor again, except with the use of NASA sprayer, you can get this one done. Number two, it makes teaching agricultural science more practical. For example, the mechanical agriculture that we use on the modern days, unlike the manual ones, make it more faster. For example, the farming, one cannot, like 10 people cannot farm 1 hectare in a day. But with the use of tractor, I believe you can farm up to 2 to 3 hectares in a day. Number three, it enabled the students to explore practical tools. Example, when Open have been supporting us for some times now, they gave us a rain gauge and a soil tester. And we implement it with our students. Some of them have never seen it before, but by the time we implement it, we use it, they saw it, and it works. So I think agriculture can be fit in the classroom. Question number 2. Okay. Okay, question number 4 is continuation. It determines the teaching strategies adapted to foster students' participation. There are some students, if you just stand on the board while teaching, they will find it very boring. But if you bring what they can lay their hands on, just like the kids that we're about to introduce, I think everybody will be happy and be anxious to see what you want to unveil to teach them as a practical. Number 5, it determines the instructional material to be used, improving teaching and learning, practicing agriculture. It's still almost the same thing. You took the kids to the farm, you bring out the technologies, like I use the knapsack sprayer as an example. Before the 20th century, there was nothing like chemical. People have been battling with insects eating our crops, and there was no massive production of food. But now, with the use of STEM, I can say, it enables us get access to more technology that we can use insecticide by using knapsack sprayer to spray the farm, and it will grow well. That is why more foods have been produced in this 21st century, unlike the 19th century. Number 2. Question number 2 says, what opportunities to include STEM concepts and practices could be added or could expand topics you are already covering in your classroom? The opportunities are, number 1, the opportunities of STEM into agriculture is the introduction of mechanized and tools and implements, such as tractor. Just as I said earlier, even 100 people cannot cover a hectare of land manually. But today, if you give tractor 30 minutes, you cover 2 hectares of land for you by farming. Harvester, also, in those days, people go to farm. Before you harvest, you have to call neighbors to come and assist you so that you fasten your harvest. But today, if you have a harvester, you don't even need to call anybody. So it will do the work, and then it will get more easier for you. Then the STEM tool lots. The kits that were introduced today, most examples she cited was in the farm. So I think that one will also help to generate more interest on the teaching of agriculture. Then we talk about rain gauge and the soil tester earlier. Those, when we were using, like in this country, most people doesn't produce more food in those days, but today you can see the massive production of food with the introduction of mechanized agriculture. And the soil tester, like those who are farming cassava, we have been finding it unproductive because of the continuous years of the soil. But today, if you're able to test the soil and you see that it fits a particular crop, then you plant on it and it will yield well. Thank you very much.
Thank you. All right, do we have any question? Okay, we have a question.
Good afternoon once again.
Yes, sir.
No, it's not question, addition. The concept and practice of STEM. Sorry, the concept and practice of STEM make agriculture easy for the student in the classroom because of these small teaching materials. So that when, you know, agriculture, if you don't see it, you won't believe. See is believing. Before, some people find agriculture as a dirty work. But now, through the help of through the concept and the practice of STEP, the students, they are able to find it easy to go into agriculture. Thank you.
Good point.
Any other question, please? Do we have anyone? Any question?
Okay.
Me, I have an observation or a contribution. Is somebody asking a question? So I'll wait.
Nobody,
okay.
ma'am.
Do you have any question in-house here? Okay. All right, doctor, we have one question.
Okay, this is my question. Now, looking at STEM, talking about science, technology, engineering, and mathematics, I see that these are science field. Now, somebody teaching art like cultural and creative art, business study, I don't know. Are you people working towards maybe having a workshop for them to see? Because I see the relevance of this STEM, like my subject, cultural and creative art, talking about a topic like revamping of shoe. Now we do that with students, revamping of shoe. You get your shoe that is still good, but maybe the leather is worn out. You get your Ankara material, you get your adhesive or gum, you get your brush. Now, technology can come in where you see that the brush is slow. You now improvise, maybe with the container, you make a hole on top, you just spray it on time, it fastens your work. Mathematics comes in when you begin to calculate how many years of material do I need to get this shoe done. Then we talk about science. When you talk about friction, the gum and the cloth, gumming it together. This is relevant to the cultural and creative art. But I see that cultural and creative art, the other department is not captured here. So are you working towards them too?
May I come in? If you noticed, we started, creative art has always been done, and things that are more intimidating in the classroom system integration, which is why we focused on STEM, especially for children with disabilities. We found that they were being excluded, so we wanted them to be incorporated. So that was the ultimate goal, right? For sustainable economic impact. To add to what you said, if you noticed in Heather's slide, she included the A for arts. So that is creative, that is visual, I'm an artist. As I'm sitting, I'm a filmmaker. We use technology, we use science, we use engineering. When you are framing your picture as a photographer, when you are directing, even a play, you say, take 2 steps forward, take 2 steps backwards. You are using mathematics. So ultimately, it's all always integrated anyways. It now depends on your creativity as a teacher to know that these are the standards for science, but I'm teaching how to do graphic design. So I'm bringing in science. I can now use that as a teaching opportunity to bring science into my creative arts class. Do you understand? So you have a great question. So we as teachers need to be very flexible. We need to be knowledgeable about our curriculum. That is why when they were talking about priming yesterday, I said you need to plan ahead, study your curriculum ahead. And now you can know you can integrate that creative arts class with what's been done in science. You can collaborate with a science teacher, actually, merge your students together and do co-teaching, because you want to make sure that you capture that subject matter. An idea that came to me when Boniface was presenting on the agriculture, I was like, why didn't I think of this before? We've seen the picture of the greenhouse that Heather has in her PowerPoint with a sensor. That is a project for your students right there. Use local materials to build a localized greenhouse. I've seen it done. And by the time they're doing that, bring your creative artist to come and design what it should look like, right? Somebody can design what it should look like. People can now measure how tall should they cut the branch that they're going to connect together. Where can they get the nylon to cover to make it a greenhouse? Where is the sun coming from to penetrate so that, you know, maximum nutrition will be there for the plants that you are growing in this nursery? So now they're going to now build a sensor that they cannot put in there. So it practicalizes, it brings everything up together. So you are using everything, science, technology, engineering, because they will build it, make them build it. Don't build it for them, okay? And that's just something I want to throw out there as a project you can actually start on at your schools that will integrate the components, all STEM and A, the STEAM component with the arts in between.
Yeah, the point that I like to make about art, just to finish that, is art asks us to make close observations and then to think creatively, right? Like if you see a painting, it's somebody's interpretation of what they've observed. Science is about observing and then thinking creatively about the questions that what we see bring up. So they're very aligned. And I absolutely agree. I think that the idea of having a group of kids do a project where they design a greenhouse is a fabulous idea of really showing that this is aligned, right? Thank you. All right, back to you guys.
All right, do we have any question? Yeah. Question or contribution? Anyone? All right, okay. So, okay, all right, we have one.
Sorry for this question. It's a funny question.
Oh, go ahead, please.
Agricultural science, you say science subject or vocational subjects?
Okay. Agricultural subject, is it a science subject or vocational subject? That is his question.
It's both.
It's both, absolutely.
That is the whole essence of purposive education. Why are you learning agriculture if it's not going to become a vocation for you in the future? So that's why we keep talking about this. We need to let the children know the potentials in what we're teaching them. Why are we teaching them, you know, science? Anything we teach becomes a vocation.
I was going to say that your example of making shoes, right? That's also a potential vocation. Being able to build sensors, that's a possible future vocation. So I think anything that fills a need in your society is a possible future career, vocation, job, all of the above, right?
And STEM really arcs back to vocation, really, because in vocation you teach all the elements of STEM generally. It's just called something else, and it's a little more science and technology oriented, electronic technology, shall we say, than maybe building a car engine. But you know, you're still being creative, and all those elements of STEM are bound and found in vocational schools. And ultimately, we want people to use science to do some meaningful things for the community or society. You know, applying your learning again to useful, practical purposes.
I mean, using the example of a car, I mean, to me, I think of electricity, I think of physics, right? Because physics is the foundation of understanding electricity. If you think about a car and a combustion engine, it's a combination of physics and chemistry that we're now looking at. So, you know, science is really just asking questions about how the world works around us. Makes it pretty much everything that we're doing in the world can be linked back to science and can come out of science and how we look at it and approach it. Great.
All right, we have one more a question or a contribution. Okay, a contribution here.
Afternoon, everybody. Anjon is my name. I would like to contribute this, especially for students with visually impaired, talking about mathematics. I could remember that many of us are familiar with these tools that we are using calculation, that is abacus. It's easy for them to make use of it in their calculation. And the frame, we have the frame, the bead, and the iron rod. And with that, for me, that's technology. help them to do their addition, subtraction, multiplication, and other simple arithmetics. And from that level, we can even introduce to them how to make that abacus.
Mm-hmm.
By doing that, that will really help them. Thank you very much.
Excellent, excellent. I like that.
Excellent example, yeah.
Abacus is probably one of the earliest computational machines that we had. So, right, you know, still useful today.
Okay. Good
All
job.
Right.
Great.
Do we have any other question or contribution? I don't think so. All right. So in the absence of, yeah. Okay, we have one more. Mr. Boniface.
I want to make a contribution that's mostly for the agri teachers that are here. After this program, the STEM program, I want, if you go back to school, you should introduce a young farmers club where you will be monitoring them and be tracking them so that we'll see how we can raise agriculture more in the school. Thank you.
Catch them while they are young. Let them develop that interest. So when they're older, they will say, I don't want to be a farmer. Let's catch them now. And that's a great way to catch them and get them involved in farming.
Even if it's just that they're going to have a home garden, you know, it's a lifelong hobby, even if it's not your occupation.
Right. And what we noticed during the lockdown was that some of our students at the foundation, you know, even those with severe disabilities, they started doing gardening at home, just from what they were exposed to in class. And we had pictures that parents were sending in with, you know, you have a child who has cerebral palsy or autism and ADHD combined. You see these children watering their gardens, you know, and they feel like they're contributing.
All right, Doctor, there's one more contribution here.
I want to add, agriculture involves both crop production and animal production. So STEM can also be applied in crop production in area of poultry, for instance. To hatch the eggs, we use machine, incubator, called incubator. So it's also a STEM. So in area of animals too, we'll use artificial insemination. The insemination we use to inseminate animal is also a technology in agriculture. So that's what I want to add. Thank you.
Absolutely. Yep.
And if I could add, you know, you mentioned animals, and I'm glad someone brought that up because there's a lot of different kinds of sensors you can make out of these. And one of the things that we have on our farm in France is they're interested in tracking livestock. Well, in this kit is also a GPS, global positioning system, to track livestock as they move about the fields. So you can keep track on your phone of where the animals are. And we're doing that in France. The other application, our farmer in Jamaica came up with, we know about this, but he has a real need of measuring the ammonia within a chicken coop, you know, for illnesses, and too much ammonia is not good for the chickens. So if you can put in a gas monitor for ammonia, which you can do from these kits, you can keep better track of the health of your chickens. So there's a multitude of different uses for agriculture, as well as, you know, other areas, fisheries, you know, this water monitoring. So, you know, I think, you know, you just got to be creative with the use of this, and have your students think out of the box of what they want to use this kit for. It's not only for agriculture, there's many other things we can do with it.
Okay, I actually like what you just brought up about the GPS, because there's a farmer in Nigeria who's told me that he chose to breed goats as opposed to cows. When I asked why, he says because cows are always being rustled, they're always being stolen. So hey, use the sensor to track the GPS to track where your cow has gone before it ends up in somebody's stomach. So that's another way. That's a funny one, but it's practical.
Yeah, they have the same problem in Jamaica. That was one of the other reasons why they want to track the animals, because there is thievery.
Okay, great. Thank you all for your contributions. Heather still has a lot to cover.
I just have
Heather?
one more thing for us to do today.
Okay.
So awesome. I'm super excited that you all came up with really great ways to incorporate the use of STEM into your various subject areas. You're here as part of school teams. And so one of the opportunities that we have is for you to be able to come together. And as our science team came up with, STEM is great for project designs, coming up with good projects. And so what I wanted was for you to come together into your school groups and be able to spend some time talking about more specifically the needs of your kids and maybe what kinds of ways you could collaborate to create STEM opportunities together, like building a greenhouse, right? You know, which is going to be a multiple teacher or could be a multiple teacher activity. You could use the agriculture teacher, the math teacher, the science teacher, you know, to talk about the various aspects of that project. So you've got 4 suggested sort of conversation starters for you to use in your schools to consider, you know, what do you already have at your school that would work well for an integrated project, cross-curricular project? Is there something you want to add to your school? Maybe your school doesn't have a garden right now, and so adding a garden might be a great first project, and then build a greenhouse for that garden, right? Do you think you need anything else for creating an integrated STEAM lessons, and then coming up with a good project theme? So I'm giving this to you now because on Friday, we're going to have some time to actually write that lesson, that sort of put that project together so that you could actually run it. Or if you want to do individual lessons to do that. But, it takes a little while to let ideas percolate and come together and to discuss. So I want to get that conversation started so that you guys can come up with something amazing. Dr. Badewa?
Yeah, there's something that I'm also thinking of that could be a good project, like somewhere talking about poultry farming. They can have this hydroponic system, where you'll have grains for the poultry, the waste will go into like a pond for your fish, so you can have a fish farm, and the water from the fish farm can now go into watering your plants. Maybe ideas like that, can all still come together as a possible project. I'm just throwing that out there so that as they're brainstorming, they'll think outside the box, think of what they already have and how they can integrate what they already have together into projects.
Yeah,
and maybe,
go ahead.
Sorry, maybe with the creative people, maybe they can draw out these things as people are like doing it.
Yep.
Have some artists drawing. If you have photography class, have some photographers take pictures of the whole process. You can develop a storybook. You can develop a project book from all these activities as well.
Yeah, we have taken, because the technology wasn't available in Kenya or in the Congo where we worked first with this, and we got them the rain gauges and we got them the analog probes, excuse me. But really what we had the kids engaged in was really observation, what you were just saying, Dr. Badewa, to reinforce this, taking pictures, sending us the information of what the rain was that week. So you didn't need the STEM kits right away, but we want to take them in stages. So you can build the greenhouse, you can start a poultry project, and then to all that, we can add the new technology on top of that, which will really enhance, the basic knowledge. So you can start small. You don't need to jump right to the sensors, but there's a lot of ways to approach STEM without having to, spend a lot of money.
Yeah. So I threw some of those ideas up on the slide so that they're there as a sort of,
Okay, I think we might need to split up in groups, right?
Yep. So you're splitting up this time into your school groups. So the objective is the teachers who have the potential of doing the project together because they're in the same school are now going to have some time to kind of brainstorm and see if they can come up with some good project ideas that are good for their schools.
Oh, can we go and maybe take our seat and, let's do this very fast.
So how long do they have?
Well, we have a half hour till it's time to go home.
Okay, so they should pretty much be done with this within the next 15 minutes so that we can come back together and discuss and present. Is that what you're saying?
No, I'm saying let's give them the 30 minutes and then they're going to come back and discuss and present on Friday.
Oh, okay. Okay, that's a good idea.
Because then they get a chance to work with the sensors and then they have time to think about how to put the sensors in. And then we're going to talk about the UDL and the differentiation and stuff on Friday. And so then they can come together with if they have a project idea to think about, they can put together and decide which project is the best fit for everything together.
May I just ask if the question you have there could be pasted on the group chat?
Yes.
And then we make some copies for the participants.
Yep.
So do you mean we are to meet at the group sessions now?
Meet in school session, yes, because you've only got 30 minutes left till they go. So just to get started now and to brainstorm a project that would work for their school to think about, and then they can go.
All right, so we have 30 more minutes for that.
If they finish before 30 minutes, that's also fine. That means they can get to go home early, but I don't think they'll finish because you know how people are too intelligent to finish. They want to elaborate more and more and more.
Exactly.
Which is fantastic. But, it's up to you guys there. You have four questions on the board. So okay. I would imagine, however long it takes you to cover that, even if it takes beyond 30 minutes, you are there with each other.
Right.
Mr. Thompson, are we clear? Okay.
Yes, please. Dr. Badewa.
Yes.
So we're meeting, and then after that, I believe we can close the session, right?
Right.
Yes.
All right, let's take some time out to just appreciate you all. You've been so wonderful, so engaging. Thank you, Heather. Thank you, George. Thank you, Dr. Badewa.
I have to also appreciate all of you guys because when I first heard about the STEM toolkits, I was like, oh my God, what am I getting myself into? But, I saw the potential and you guys, your questions have actually given me more clarity on the potential of what we're doing here. So I have to appreciate you also for the openness, for being, kind of like you two were like thinking outside the box as to how this would work. And you got it. So thanks for your knowledge base. Thanks for your professionalism and your attitude, your positive attitude and your reception of the whole idea.
And I want to thank Mr. Thompson for a wonderful job as an MC today and the camera people and everybody behind the scenes who really made this work because we're, how many thousand miles away from you people and yet carrying on a STEM lab from 4,000 miles away is a challenge. So you've made it easy for us. Thank you.
Thank you too. The media team.
I'd like to give a shout out to the teachers, because you guys have been engaged and participating and working with us, and it's really amazing and wonderful. And what you share with us helps us then bring more value to you. So thank you very much for your candor.
Shesheni. Shesheni, man.
What does that mean? Mr. Thompson with multilingualism.
That's good.
That's a bond.
All right, ça c'est bon. Muy bien. Très bien.
C'était tellement bien. Ça, c'est vrai.
I'm lost now.
That language
Okay.
I can handle.
Yeah, French I can grasp a little bit.
All right, good. Looks like they are getting to work.
Right, so I'm taking my camera off
Yeah.
and mute myself.
Mm.
Eda, please, I need you online.
I'm here. I'm here.
Are we expected to present as a group or as a school or individually?
So the idea here today is to brainstorm a project. We're going to come back to that project on Friday, and that's when they'll present them.
As a school?
As a school.
As a school, good. Thank you.
Ideally as a school, because the goal is cross curriculum, if possible. So
All
like,
right.
you know, a blended.
Thank you very much.
Oh, thank you.
Right, I'm at the stand at the group session for Abuja 30. There's a little concern with security. The school is having issues because they don't have a perimeter fence. So they are saying that they are a little limited with what they can do. But they are trying to see how they can either implement that strategy at a place that is closest to a teacher's home.
That sounds like a great idea. I mean, you have to work with what you have. Another suggestion might be to think about the idea around like the aquaponics, which can be done inside, where you basically establish a fish tank with plants growing on top of it, and you can build a whole cycle of fish and plants nourishing each other. So if they can't find an outside place to work, that might be like an in-building thing that they might be able to do.
So they can do that at the backyard of a teacher's home?
Yep, perfect. Yep.
Okay, thank you. I'm moving on to Kwali. I just finished interacting with junior day secondary school, Kwali. They are trying to, they have a couple of projects as options.
Great.
But there's really no serious concern at the moment.
Yeah, so the idea is after they have a chance to work with the sensors, it will give them a better idea of what they want to do for a project. So having a couple of good ideas to start with is fantastic.
But I would like you to give a better, more like explain further the idea of the aquaculture.
Aquaponics. Yep.
Hydroponics plus fish.
Yes. So aquaponics is, you know what? I'll pull up a picture of it tomorrow so people can take a look at it. But basically, you're taking a fish tank and you're planting plants across the top. So the plants are getting their nourishment from the fish tank. The fish are providing the nitrogen cycle to it. So you end up with this nice, really full ecosystem that can have food that's growing along with growing fish, like a tilapia that you can actually eat. So it's a really very fascinating system that allows for an indoor type of agriculture practice that is not just plants, but also has an animal husbandry piece with the fish.
You can see samples.
Yeah, you can Google it, but I'll find an example just to show everybody tomorrow.
Yeah. I've seen this in Nigeria. I've seen this particular one that's about to come up. I've seen this.
I'll stop sharing.
And yeah, people, okay. Can you see my screen?
I have seen that you have started sharing. Yes, there it is. Yep, exactly.
Okay, I've seen this in Nigeria in a couple of places. So there are different ones that can be made. You can get creative with it. I haven't seen this, but I know this is very, very possible.
Right.
And
so,
right,
exactly. And then like the one that's on that you're showing now with the fish tank is one that's easy to do if you have an inside space. You can see they can be done in greenhouses. So it's the fish are actually providing the nitrogen and some of the other nutrients for the plants.
Yeah.
And it can be done really with what have you. Like you could do this with a barrel, you could do this with, you don't have to, again, it's not something you have to go out and invest in a whole lot of expensive equipment. You can pretty much put something together that will work pretty well.
Yeah.
Can I come in?
Yes.
Yes.
There is a fantastic concept from the School for the Deaf. I don't even know how to explain this, but let me start. George, you would love this. I'm telling you.
I'm looking forward to it.
All right. They intend to start out a fish pond.
Mm-hmm.
A fish pond. The fish pond is going to be having the poultry farm just right above it.
Mm-hmm.
The feces of the poultry birds would be used as feed for the fish. That is 2 projects combined in one.
Mm-hmm.
And then right beside the pond, they intend to plant vegetables, tomatoes, pepper, okra, ugu leaf. I don't know again, whatever they want to plant. But as many things they intend to plant, they intend using the water from the fish pond to serve as irrigation, to all the plants around. And
Perfect.
they intend to have another animal farm section right beside it, like a ranch system.
We can't hear you.
Lost you.
Your audio went out.
Maybe the battery is
The battery
dying.
in the
We
microphone
need
might be
batteries.
on, yeah.
Yes, we're running low. Today is day 3. We need to recharge. All right, right away, I stopped right where, you know, they want to put up a ranch system right beside that. I believe that's a 3-in-1 project. So it's going to be the 4th project combined.
Yeah.
Where the ranch system is placed by the side. They intend putting the goats. What other animal? For now, goats. They can put cow later.
Sounds like they're going to have a very profitable farm.
Yes.
Yep.
And then they intend to use the waste from all the domestic waste within the school, because it is a boarding school. So the domestic waste that comes from the boarding school is used to nourish the goats. I think that sounds robust.
It sounds very robust. It does indeed.
Very organic, very organic.
Yes.
Yeah. Awesome.
So they are
Yeah,
good.
I think that's a great idea, great projects. At the foundation, we also want to do the pyramid farms. You know, it's just that we don't have enough space to do that within the school compound. So we're looking to see how we can get a couple of pyramid farms together, do some greenhouse farming, because we really want our students to start selling what they grow. Now, what they grow, we eat. You know, they cook and we eat, which is another way to integrate this, you know, in the classroom. Once they start growing, they can start cooking. Use it to teach the cooking class and let the children cook with what they've harvested, you know.
Yeah, that's a great way
There
of
you
doing
go,
it.
the farm to the table idea.
Yep.
Right.
Brilliant. I think we're on our way.
Absolutely. Mr. Thompson, you were going to say something.
Yes, I'm actually at the stand for the Royal School of Educational Therapy Foundation. I'm trying to extract the concept notes. Then I'll get back to you. Thank you very
They're
much.
not giving them, are they?
Our idea, we're not sharing.
From cooking to coding, yeah.
We've already shared the idea. We share the same idea. I mean, we have the same idea as Kwali. We just don't have the land. So we use our little garden space right now at the school.
Yeah, it will get
Doctor,
there.
that is an expo.
Which one?
You have given them an expo.
They've been doing these things, so they should be even telling you what they're already doing. They're doing it already.
We want some goats in your compound.
The pressure is on.
Yep.
We'll be kicked out of that estate if we bring goats into the compound.
Doctor, you need to relocate to the village. Your foundation go to the village. You have goats live around you.
Yeah, your permits will not be renewed.
Give us land in the village, we'll be there.
What is your challenge? What is the issue? Okay, they've indicated that land is a challenge for Royal School. What else?
It is.
Okay, they need little mechanized technology, little mechanized tools for gardening, weeding, and all the likes. Great, ridging and all the likes. So that is, I think, a little.
They need to start brainstorming on how to raise funds to get these things.
I think this will be an ideal system to implement the hydroponics. Am I right?
Yeah.
Mm-hmm.
Yep. Yes.
We have a fish farm. We already have a fish farm.
Doctor, is that also in line with your concept notes? Having an hydroponic system?
We've even submitted a proposal for something like that. You know, Mr. Sampson is there. We've gotten the design. We've even spoken to the people who fabricate it. The guy, I believe, is in Liberia or somewhere or the other like that. So, yeah.
Thank you very much.
We need land and we need money.
Doctor?
Yes.
Yes, my attention has been drawn to the time.
Yep.
Okay.
The time is 3 o'clock on the dot.
Oh.
Well, we will see everybody tomorrow.
So I'll quickly want to appreciate everyone. Please, let's put our hands together for this wonderful session. Day 3 is over. I want to thank everyone and
thank you, everybody. Yes.
What next?
Tomorrow is just about the toolkits, right?
Putting the kits together. Yep. Hands-on.
Hands-on, deep dive into the actual sensors.
All right.
I was
doing
some daily monitoring.
I guess we can call it a morning.
Yeah.
I'll call on Mr. George to close the meeting.
I make a motion to close the meeting. Does anybody second the motion?
Everyone.
Everybody who's going back to bed over here seconds the motion.
Nap time.
Thank you, everybody. We'll see you tomorrow.
Looking forward to tomorrow. Bye.
Bye now.
Be punctual tomorrow. Thank you.
Thank you, Mr. Thompson. Take it easy. Au revoir.
Au revoir.